we have a system of power asymmetry where we have a lot of, some people call it, Shoshana Zuboff calls it surveillance capitalism, but there was a lot of discussions around all this power asymmetry. That is the fact that there is a big discrepancy between sort of us as controllers of the data, as I don't like to use the word owners, but as data subjects, and the other side, and the companies using and leveraging this data. Then we have the other development of the landscape we're in is around the harms, and that we are understanding what are the harms that these systems are creating. So one is an individual harm. Then we said, we talked about bias, we talked about the element of fairness, but it's also the bias, and so the impact on society, and that could be representational because, for example, social media or they continue to they leveraging the systems and leveraging patterns of behavior, they continue to create echo chambers, or because they continue to advertise jobs they pay less to women and jobs that pay more to men. That means I talk about representational harms when the systems are creating the harm of perpetuating on a larger scale what are the stereotypes and the inequalities that we have in society. The other challenge that we're facing at the moment is around transparency, which is on what it means for a company that uses AI or an algorithmic decision making or whatever it is to be transparent with the users in a way that transparency is meaningful. And we have come a long way on this. We have been in a situation of having the sort of think about privacy legislation, which is very much rooted into the concept of consent, and that consent is rooted on 3 pages of privacy notices that nobody reads. You navigate the internet and you just go, yes, accept, because it's really difficult to exercise their real control because you don't often know. So we are in these situations where we're looking at ways, and we should be looking at ways through the interesting new way, user interfaces and but to make that transparency really meaningful so that people can really understand what is going on, especially when we use much more complicated systems. And that leads me to the illusion of control, that is very much happening and that we're witnessing in the digital ecosystem. This is leading to the other, sorry, this is going mad. So this is leading me to the final sort of element here, which is, I don't know why it keeps changing. Anyway, so which is leading to the final element that I wanted to discuss, which is around the legal element of this and what is happening. So as you may have heard, the European Union is working on what is called the European AI Act, which is a legislation that will be, I think, almost finalized by and then ready for next steps in the spring, not 2022, 23, which focuses on defining what is high-risk AI. High-risk AI is defined in 2 ways. Is a component of AI systems, systems which are already defined as high risk. So that means, for example, medical sector, manufacturing, and all these traditionally where you see things like conformity assessments or CE marks, where they're already sort of areas where already there is due process to be followed, to be adhered to, and therefore AI is part of this. Or there is a list of high-risk AI which is defined and by the European Union, which is, for example, things like the ones we've discussed, the use of AI in HR, and similar. So the European Union has adopted this approach. So high risk is where there is a higher risk of breaching the fundamental rights of individuals, and whether this is privacy or whether this is discrimination and all of that. One of the key things of all this is that high-risk systems, they have to demonstrate that they follow due diligence. So one of the key things that companies need to do now. They need to make sure that they future-proof the products that we create, because in 2 years, 3 years down the line, there'll be this legislation to comply with. But regardless of the European AI Act, the General Data Protection Regulation is already here. So already companies have to make sure that they are transparent. They provide a degree of transparency and explainability, and we'll come to that in a second, or that they provide individuals the ability to contest the decision under certain circumstances, and then in particular that the way that they process their data is fair, so that to audit an algorithm or audit a machine to verify that it's not biased is a duty already, is a requirement already under the General Data Protection Regulation. Now, I want to conclude on the issue of how we make sure that all this happens and what I think the main steps should be. Before I do that, in just 1 minute, I wanted to sorry, just go back on this to show you that there is a sort of global alignment principles around this issue. So whether it's the council, whether it's sorry, Michael, the slides keep going up and down. I don't know what to do. Okay, hopefully they stop here.
I don't know why that is happening. I mean, I guess maybe, Ivana, if you wanted to exit out of presentation mode.
Yeah, I think I will, because they just keep going.
And then so you could display the slides, but maybe not in kind of presentation.
Oh, that's
mode.
true. Yeah. But anyway, that doesn't matter. So I will just mention 2 last things. One is that there is a global alignment on these issues. So we have the European AI Act. The Council of Europe has issued the Council of Europe the Convention 108+, which talks about these issues as well, issues of transparency, issues of fairness. The US is going quite strong on this. You may have heard that the FTC in the US, under the new leadership on Khan, is quite strong on discrimination that comes from an unfairness when is automated. And the Biden administration have been very clear that they wanted to issue a new sort of bill protecting individuals in the age of the AI and algorithmic decision making. Washington State follows suit. They have and similar legislation being introduced around accountability, and New York City Council just, I think, a couple of weeks ago approved a new bill that it forces companies they use versus New York City to audit the systems for fairness and transparency before they get deployed. And we've seen also case law, which has been quite interesting over the last few months. We have seen Deliveroo and Foodinho being basically told that the way that the way that these food delivery companies were assigning shifts and defining the trustworthiness of a delivery person was wrong, because what was happening is that in Italy at the time, what was happening is that the delivery person was logging their preferences and their shifts onto the systems, but they were given a trustworthiness sort of code based on how many times they had cancelled their shift in the previous month. And the court said, well, but the reason why people cancel maybe so many different can be different. It could be because that individual needs to look after a child, or because they need to attend a strike, which is safeguarded as a right in Italian law. And therefore, by not differentiating the reasons for cancelling a shift, you are automatically introducing discrimination. So we have seen, we've seen a lot of cases happening. We've seen data protection authorities stepping it up and starting to say, how do we deal with privacy, fairness, and explainability and transparency issues, which are the core of privacy law in the EU in the age of AI. And there's going to be a lot more to be seen in this area. So if you are an organization and you want to deploy these technologies, a few just steps that are very important. The first one is create a definition of fairness. What is the definition of fairness that an organization wants to adopt? There are many different definitions of fairness. So many. Fairness could be the UNI's the same starting point, or could be the UNI a different starting point, depending on where we come from. Adopting the wrong definition of fairness could lead to unfair outcomes. And so it's really, really important to understand what is the definition of fairness that we're looking at. The role of the DPIAs and data protection impact assessment, some people call it algorithmic impact assessment, AI product impact assessment, whatever it is, but making sure that there is a very structured approach to looking into this. And then the timeline for fairness intervention. So at different stages, the pre-processing, the in-processing, and the post-processing. And then the importance of the biasing techniques. So at the moment, there is a proliferation of tools coming into this, saying weaken the bias. And yes, I mean, the biasing machines and the biasing techniques are important, but they need to work as accelerators and alongside humans, not replacement. And then I always say, reward bias spotting. Instead of crashing any sort of discontent or any sort of criticism, it's really important to reward bias spotting. And the final thing is to have a very diverse workforce, because without that diverse workforce, it's very difficult to identify whether an algorithm can be biased or not, as you can see from this. So that diversity in the workforce is absolutely crucial. So that was an overview from me. I would love to take questions, comments. There was one here.
Yes, thanks. Yeah. And please, as you know, if people have questions, please put them into the chat there. Thank you very much for that presentation. I think it's very interesting. As I said, there is already one question that's I think there's a couple of parts to this question that's already in the chat. There's one part of it is, well, the major question is what can researchers or developers do to prevent their inventions being used for unethical purposes? This is the challenge, that you might develop something as a researcher and then others will take that and put into a context that you might not like. So I don't know, do you have any thoughts on that?
Yeah, so I think I would say two things. I would say that, first of all, over recent times, we have seen a real activism coming from researchers and developers. I mean, I've been really, really impressed. It's been incredible. We've seen, especially I have to say in the US, but we've seen researchers and developers really taking a strong stance and saying, well, I don't really want my products to be used for the wrong thing. And this has forced a real change in some areas. I don't know if you remember situations like happened with Amazon, that was using that was selling their facial recognition systems to borders agencies during the Trump era, when kids were caged. And the researchers and the developers at Amazon, they rebelled against this. And you look at what is happening. I mean, look what is happening in the US, for example, where some of these people have gone into having key roles in the FTC. Meredith Whittaker, for example, who organized the Google strike. She now works at the FTC in a can. And others. We have seen more and more of these things happening, where researchers and developers, they've actually been at the forefront of this, so of the ethical use of these machines. And obviously, it is a researcher, as the question says, somebody else will take it, yes, but it's also important to expose these things, and things are being exposed, and companies are being more and more held accountable about all this. Just to look at what is happening with Facebook and what is happening with the Facebook whistleblower. Now, obviously, Facebook, Amazon, I'm talking about big names, and that intersects with the issue of competition, antitrust. But even on that, there is now action that is being taken by the US, but also by Europe with the Digital Market Act and the Digital Services Act that is trying to put sort of a limitation to all this. So yeah, I mean, this researchers and developers, they are actually playing really an amazing role within all this.
Thank you. Yes, that's a really good point. That we do see this activism by researchers and developers. Although there are still, as you mentioned, as a person asking the question mentioned, sometimes there are situations where a person walks away from ethical reasons, and then others unfortunately just carry on the work anyway.
Exactly.
But I think it's I don't know what's going on here. There's something popped up about breakout rooms. Anyway, there was the other part of that question was really about whether is the invention or the algorithm itself the problem, or is it the use of data to train and then deploy these technologies? Where do you think?
Yeah,
the problem
I mean,
lies?
I think it's a great question, and we've seen this. So, for example, I always give the example of facial recognition, right? Where a lot of people say we can't use facial recognition because it's biased and discriminates. And obviously, yes, it's true. But if we have a facial recognition tool that stops discriminating, I believe that even its use would be discriminatory, because you would end up deploying a tool like that, maybe in some particular areas and not others. And by doing so, by virtue of using a system like that, you would end up discriminating anyway. And the same, so the problem is a very important issue. So for example, the European Union, what they've said is we will ban certain things. We will ban the use of social scoring systems, like what is happening in China. That's the view of the EU. They say this does not apply, so not comply with the values of Europe. The social scoring is where you are scored as a citizen, and then that limits the way that, for example, you can access a school, even schools, or you can get a loan. And this is because the surveillance system enables you to be watched the whole time, and by the virtue of being watched all the time, they can score the way that you behave in as a good citizen. Now, the European Union said we refuse this, and that's not part of the values. Now, again, the question is always, is it the system, or is it how it's being used? And some people say, well, technology is neutral, so being neutral, it can be used in any way. I actually disagree with this, because I think it's a matter of affordances. It's a matter of what is that technology capable of doing. And by actually thinking of the affordances, I think technology would appear much less neutral that is defined, and I think we need to really take it into consideration. So the idea that we just do not have some particular tech, I think, is quite important. So the idea this is a very personal opinion, but the idea, for example, that we do not have automated weapons that kill, to me is essential, because it's part of it's part of human life. But people might have different opinions. But I think it's important to see technology not necessarily as neutral, but as sort of having affordances that need to be taken into account.
Thank you, Ivana. That is a good perspective. If anybody else has further questions, we have another 10 minutes or so. So please, people are very welcome to post further questions in the chat here for Ivana. I think you gave made some very interesting points, and about the key point about data not being neutral. And
there is an interesting, there is an interesting question. There's this question from James: could the automation of existing inequality be a good thing? Fixing non-automated inequalities seems. I don't seem to be able. There's something wrong, but I don't seem to be able to read the question.
Well, I keep reading it then. Fixing non-automated inequalities, e.g. via education of individuals and reform of institutions over and over, seems to be very difficult. If we make our tacit unequal processes explicit, for example, in codes or models, the inequality becomes more visible. And if we then take measures to address it in the code or models, it is addressed everywhere and more reliably.
Sure. Sure. The problem is, if it happens, so the thing is, yes, I mean, you could argue, let's use the system to identify the inequality. I mean, let's use AI to identify the inequalities and then let's fix them. I mean, I'd be 100% in favor of that. The issue is that what we're seeing is the opposite. What we're seeing is that, for example, let's talk about sort of women's rights. And what we've seen is that, you know, we've been fighting for many, many years, achieving some, but not much. And then these things are coming back in a way of automated systems. So, I mean, it's not happening. It's not that it's, but I would be absolutely in favor of that. And I do think that, for example, these tools can be used to say, okay, let's look at which students are achieving, you know, are being given lower grades, and then let's do the opposite. Let's, you know, reward them, or let's look at why this is happening and understand the systems and trying to fix it. Yes, that is what I argue for. Yeah. And but again, companies have got their, I think companies have their have an opportunity here, which is to, through their understanding and interpretation of fairness, and through the use of these technologies and their ability to tell a story about how they're using them, they have the opportunity to show to the customers and clients and society where they stand. So that is an opportunity for organizations, you know, by having, I always say, you know, we used to say this in privacy, and it's really important, you know, it's the storytelling. You know, I always say we need storytellers in this. You know, companies should have a storyteller that tell us a story about how they're using this technology, what are the choices that they're making, and telling all this in a way that resonates with the customers, that has different degrees of technicism depending on the audience, and then can really show the values of the organization. Thank you.
And I think, you know, obviously James is putting this forward as a devil's advocate question. I guess, though, it could only work if we had absolute transparency. I mean, if you could take your kind of all of your historical data with all of its biases and encode that in something that had, you know, great transparency, then and would lay those biases bare. Whereas I think in the real world, and we do not have transparency in the decision making or in the implementation of systems.
Exactly.
Now, Ritesh is asking, what does evaluation bias exactly denote in the broader context of AI? So I think you had on one of your slides, you had a whole kind of the life cycle of say algorithm development or machine learning development, and you had biases along all the parts of the pipeline with historical representation of measurement, learning, evaluation, aggregation, deployment. So I guess, Ritesh,
yeah, I mean, that's as simple as that. In the criteria you identify to evaluate, they are subjective. That's what it means.
Okay.
But ultimately, you know, every single decision. I mean, there's a fantastic quote. I don't know if you remember. Was it from? What was it from? This is an algorithm is an opinion in a code. Do you remember, Michael?
I don't know who said that, but that's a great. That is.
It's really good. Yeah. I think it was I can't remember her name. An amazing leader in the US in this field. But yes. So the way that she was saying this is because everything, you know, from the way you evaluate the performance, the criteria, the features, the parameters, everything is ultimately is a decision made by individuals.
Yes, and as you say, an evaluation bias it's that the criteria for success, or the criteria by which you choose one algorithm over another, or one settings over another,
exactly,
encodes your own expectations, your own biases as the developer of the system. Great. Thank you very much for that. Any further questions, anybody, for Ivana? Still have a couple of minutes left.
We have, if you're interested, we have this organization called Women Leading AI, which is not just open to women, it's open to everyone. And it's really interesting because we're looking exactly in these issues and in these issues. And we have an amazing meeting on the 12th of, the 13th. We always have our meetings at 5 o'clock in GMT time. And this is with Frank Pasquale, who is an academic in Brooklyn. and he is leading on the idea of a licensing sort of approach to AI systems, and he's an extremely clever academic. So if you Google women leading in AI, then you can see this event on the 13th. If you all want to join, that'd be great.
Okay, thank you for that. We'll watch out for that. I think we nearly need to finish up, but I would, before we finish up, I would say, as an observation from my side, well, first, I think there's an awful lot in there and a lot to learn from your presentation, and thank you very much for that. I think that perhaps a lot of this applies to kind of computer systems generally, algorithmic systems generally, and not just kind of artificial intelligence, more kind of narrowly defined, where we might think of it as being, where we're, a set of algorithms around machine learning and so on. Because algorithm, do you think this is a kind of a broader discussion about the use of databases, the use of any time we're trying to, I think, as you talked about, encode.
Sure. And if you want me to end on a very polemical note, I would say that at the moment, what concerns me about the European AI Act, for example, is the idea that the Commission wants to narrow the definition of AI, which to me is extremely problematic for the reason that you're saying, because this is like a far wider thing. So by narrowing the definition, I think we're going to miss out a lot of these things that maybe not AI in itself, but in a much narrower way, but they interject and therefore they become part of it. So this is a really interesting, so the Parliament, they want to retain the definition as it is. But if there is one issue that, leaders in the space as you and people listening from sort of business, it would be really interesting to really try and understand what is the impact, what would be the impact on limiting that definition of it.
Yes, that's a great question. As we know, that some AI is often defined as kind of computer systems that do tasks that humans require intelligence to do. But the problem with that's a sort of a shifting definition, because once a computer does a task, we start to say, oh, well, that clearly doesn't require intelligence. Like, I suppose 50 years ago, being able to do mental arithmetic to add, multiply large numbers in your head, that was a sign of intelligence. But once we invented calculators, then, okay, well, actually, that's not intelligence just because you're able to multiply numbers, because clearly my calculator is not intelligent. So this is the problem of sort of shifting definitions. And whenever I can see what you're saying there, that there's a real problem if we define AI too narrowly. Then we will exclude a whole 100%. Bunch of automated decision-making systems, and people can circumvent them, say, no, this isn't really AI, this is just, I don't know what, if statements. Okay, look, I think we'll wrap up there. Thank you very much, Ivana.
Thanks to you.
It was a really interesting presentation, and thank you to everybody who contributed and everyone who attended this morning. We had a great level of attendance, over 60 people. Thank you all very much for that. So I'm going to wrap up now, and we'll hand over to our next speaker. So, and our next moderator, Sarah King, will be introducing those speakers, Peter Corcoran and Gilbert Costache. And that's, I think, starting on the hour at 11 a.m.
Okay, good morning, everybody, and thanks for joining us. My name is Sarah King. I'm a developer in HPE. Just before we start the talk, we're also using the summit to highlight courses that are available to people to increase their AI knowledge as well. And I am one of the recent people that completed the MSc in AI in Artificial Intelligence online. It's a part-time program over 2 years that's available in NUI Galway. It's fully online and asynchronous, so it means that it can be done part-time while holding down a full-time job. So it's done within a weekly cadence, but you can pick your time as and when you are able to study. There is live discussion sessions, but they are optional. The only exception being that the exams are on campus in December and May each year. There's 2 to 3 exams each time, and there's a bit of downtime afterwards. And it's actually a nice opportunity to meet your class as well, face to face. The fee is part subsidized by ICT SkillNet, and many employers do fund their employees to do the program as well. The program itself, it gets students to gain meaningful experience in data science with challenging programming and quantitative assignments, with modules in machine learning, statistics, AI ethics, deep learning, and more. There's also a large capstone project for independent study with the facility supervisor. And, it gives some people an opportunity to work on employer-related programs. Overall, it is a very intense experience to keep up with the program, but very valuable and rewarding. So the details of that are online, and I'd encourage anybody, if they're interested, to go and have a look. So with that, I'd like to introduce our next two speakers, who are Professor Peter Corcoran in NUI Galway and Gabriel Kostak, who's the Senior Director of Engineering in Experti. So their talk is on a collaboration to deliver AI at the edge for smart toys. The talk will take about 30 minutes with 10 minutes for questions at the end. If you have questions, just please chat them, post them into the chat button, and we'll do our best to answer them at the end. So looking forward to the talk, and thanks to Peter and Gabriel.
Okay, thank you, Sarah. So we're going to do a two-part talk today, and I thought it would be good just to reflect a little bit about where we are today with ICT technology, and also to talk a little bit about what we call the edge, because AI at the edge is a new coming technology, and this, I believe, will solve a lot of problems and a lot of the concerns about privacy. So let me start first very briefly with, this is me, I'm an IEEE fellow. If you look up in the top right-hand corner there, you see a bit.ly link. So that actually links to this presentation. If you can see, it's fairly straightforward. You should be even able to memorize it, but it's on every slide. And if you really want to find out more about me, I'm on Google, Google Scholar, pretty easy to find out more about me. Now, in this talk, I'm going to do a lightning 40-year history of ICT in about 4 minutes. And then we're going to look at where we are today and talk a little bit about Edge AI and what it means to someone like myself or Gabby. So some people think the edge is having stuff working on your mobile phone, but we go even deeper in that one. So let's first think back. I remember in the 1960s, I was still just born, but as a child of the 60s, I appreciate that there was a time when people had a whole floor of a building housing a single computer. And we had all those large kind of reels, and things were a lot different than they are today, and in the same, still very much the same, because we kind of got there in a big circle. In the 1980s, then we had a big revolution, and suddenly we could all have our own computer on our desk. And the next 2 decades inspired a huge shift in how we use computers. They became very much commoditized entities. And of course, we both know the two gentlemen here. Then sometime in the early 21st century, people figured out that they could actually put lots of computers into one computer, right? They could create virtual machines. And this started a whole new revolution in computing and ICT technology. And, within, let's say, a half decade, suddenly everything started to move off our computers and up into something, the mythical cloud, okay? And today, I store very little data on my actual computer. It's all sitting out in OneDrive or in Dropbox. And I'm even getting to the point where I have too many of these cloud storage and cloud services, and I'm trying to figure out how to rationalize them. But that's how we're all using computers, and it's almost become a habit. Then in the 2010s, starting 2007, Steve Jobs decided he'd have another go at the iPhone. Now, in fact, handheld computing devices, people have been trying to make them since the 1970s, 1980s. And I've written some articles on that. It's amazing how many times people have tried to get it right. 2007, we could say Steve Jobs did actually get it right. The technology was in the right place. And suddenly, in the last decade, we've all suddenly found our lives controlled by this little slab of computing technology that we carry around with us. These phones have started to become incredibly sophisticated data collection and, in fact, data generation devices. And as most of us know, the internet now is driven by video content. And effectively, we've become huge sources of data creation, right? We are the data, as I'm fond of saying. From around the mid-2010s, data got big and big and big. Well, it was big already, but it became so big that people realized businesses could be based on processing and managing all of this data. And suddenly we started to get artificial intelligence in the mix. All this data could be processed, but it could also come into our homes in the form of things like smart speakers and new technologies. And that leads to my ecosystem kind of today's computing technology, which extends from the cloud at the middle. On the outside, you find our smartphones and the Internet of Things, as it's known. But what we consider to be the edge is actually in the device, literally in the chip. And you'll see that in Gabby's talk. He's going to show you some tangible chips and you know what we're going to put in the smart toy, which is based on this chip technology. But going back to all of this evolution, in the mid-2010s, companies started to get very big and fat based on data, processing data. Google, which has started as a search engine, became an advertising behemoth. And all of that was driven by, again, our data. And suddenly in 2018, Cambridge Analytica happened. And the world woke up. Now, I had actually been writing papers before this. And I had one basically in 2016 at the Internet of Things conference. And I've presented there a few times, but on this occasion, I suggested there should be a privacy framework for a privacy responsibility framework for industry. I was literally laughed off the stage. People said, well, why would you care? What's this about? You know, who cares about the users? But in 2018, everything changed. And these days, corporate reputations depend on how you treat your users' data and on privacy. It's a huge shift in the whole paradigm around data. That gets us to neural accelerators. Okay, and what are these? We know AI is all over the place, but most AI is essentially based in the cloud. So if we look at AI in my map of ICT technologies, if you look there, cloud technology, of course, demands data that comes from our video sensors, our cameras, or from other sensing technologies. Our audio voices are picked up by smart speakers, all goes into the cloud, gets processed in the cloud, large data centers, the results come back down. That's cloud artificial intelligence. Mobile or edge artificial intelligence, which I've also written about, is really when the intelligence is more local. It's in your smartphone or maybe in your TV set. And it's accessing some data and it's processing it there rather than sending it, most of it, up into the cloud. The edge AI is when all of the data collection and processing happens in a chipset. And we'll see some details on that and we can possibly discuss in the panel. But the whole idea is, in order to save energy, that data never leaves the chip. It never even goes into memory. And that's why edge AI is a really important technology, and I believe this decade will be the decade of AI sitting in devices. You can buy these devices today. I've got a student who's done work on the Xavier and Jetson platforms from NVIDIA. We've used previously in some of my lab courses, we've used a neural compute stick from, which was from an Irish company originally, Movidius, but they were acquired by Intel. Now, one common thing you'll notice in most of today's edge or embedded artificial intelligence systems, they can do a lot of stuff, they're quite powerful. They've all got heat sinks, right? Because they use a lot of electricity and a lot of energy. But when we talk about neural accelerators, and this is the year of the neural accelerator, it's the first year you can get these things in production, they're actual. It's a chip that doesn't need a heat sink. And I give you one example here on the right in the picture is from Perceive.io, is actually a spin-in company from Experti. And it takes things up a notch, an order of magnitude in processing, and 2 orders of magnitude less energy. That chip uses less energy than a light emitting diode. Okay, that means it doesn't get hot. And what does that mean? That means you could put that chip or that piece of silicon, which is 5 by 5 millimeters, you could put that in an SD card, and you could have literally a data center level of artificial intelligence in the SD card. It can process multiple neural networks. We'll let Gabby talk a little bit about that. What that means is in 2020, well, 2021 now, artificial intelligence has been freed from the constraints of cloud computing. You can put your networks into a chip on your device. And that gets us to the David project, which Gabby's going to talk about next. I guess while we do the switch over, we could possibly take a question, but in the meantime, I'll hand over and let Gabby grab the screen.
Thank you, Peter.
I might have gone a minute or two over, Gabby, so I'm sure you'll be excused if you need to go over a little bit.
That's okay. Okay, if there are no questions, I can start. Hello, everyone. My name is Gabriel Kostake from Experti, and I'll discuss a bit about one of our initiatives to use AI for the next generation smart toys. A few words about Experti. I'm not sure if you're familiar with us. Experti is a relatively new company, is what we call a house of brands. Some of the brands you're familiar with, the DTS, the sound company, IMAX Enhance, Tessera, TiVo, the TV company from US. We are, like I mentioned, a public company. We build, license, and offers a wide range of products, technologies, and services in different markets, such as automotive and consumer electronics. We have more than 40 offices worldwide. In Ireland, we have an office here in Galway, in Parkmore, and one in Limerick. The office in Galway is part of a company called Photonation, which was founded by Peter and Petronel Bijoy, which is currently the CTO of Experti back in 2000, slightly earlier than that. And it was acquired by Tessera in 2008. We have more than 1,000 engineers, a wide and broad IP portfolio. And our technology has been deployed in more than 100 billion devices. So it's very likely you're using our technologies in all devices you're using day by day, being a phone, in the house, TV, the car, and so on. So just to touch a bit about AI, to differentiate between AI, which has to do with anything that a machine does to mimic human behavior, machine learning, which is a subset of AI, which uses statistical algorithms to learn from data and then make a decision based on what was learned, and deep learning, which is a subset of a machine learning algorithm that uses structures to create layers in form of artificial neural network that has they're very powerful to learn from and make intelligent decision based on analyzing data. Okay, so for us in our area, when we refer to AI, we usually refer to this deep learning type of algorithms, because deep learning powers the most human-like artificial intelligence. But these terms are used loosely, and they can be interchanged. For us, deep learning, when it started to become popular around 2013, 14, it was a revolution. It really what made some of the technologies that we were developing back then, which were using standard machine learning, to a new level. The signs were there that this is the future. The bump in performance for typical computer vision algorithms and even speech understanding was huge. On specific tasks, AI algorithms based on deep learning reach, or in some cases overtook the human performance. So it was clear that this is the way forward, and if we want our technologies to continue to be state of the art, we need to use this kind of algorithms as well. But these algorithms are very complex, so we even when we started to develop these algorithms on the platforms that existed at that time, it was clear that there was not a chance to make it run in real time on consumer devices, which was our main market. But it was a clear sign that this is the future, and we all know once the technology is there, the hardware will catch up. Peter presented very well the difference between AI in the cloud and at the edge. On the cloud, you have the sensor in your device. The data is being sent to the cloud. It's no longer your data. You don't know what happens to the data. It can be used for, depending on who has the ownership of the data, but the devices can be hacked as well. So it's a major privacy issue. The other issue is of latency as well. Internet can be very fast, but still you need to get the data transmitted to the cloud, gets analyzed, and you'll get the result back. Very easy, very straightforward deployment use case, but with major issues. There are some use cases that I'll present where the latency that this introduces is very important. On the other hand, if you do it at the edge, either with normal computing accelerators, CPU, GPU, DSPs, but more important, with dedicated hardware that are capable of running these very complex algorithms very fast and ideally with very little power requirements. And AI at the edge, machine learning at the edge is what we were doing before as well. This is what our market is. We are developing technologies for consumer devices. So use cases where we need AI at the edge are for devices, for example, that are always on. In automotive market, if we want to analyze the driver state, we cannot afford the latency to deploy it on the cloud. Smart IoT, AR, where you have very small devices and so on. These are the markets where we operate. Two examples that we have here, technology running on the mobile phone, and the other one, technology running in the car. And we analyze the driver and the passenger and so on. AI at the edge is what enables the deployment of this kind of technologies. Few words about smart toys. We are a technology company. We don't make products, actual products. We make technologies for products. Being a technology company, we need to see what will be the products for the future and to be prepared with the technology for these products. One market is the toy market is huge, okay? And the idea of having a toy that can interact with a child, can help with the development of the child, can develop together with the child. It's safe, it's secure, it's trusted, and so on. It's something that probably every parent will like. And of course, there were attempts to have toys that have some kind of interaction. Okay, these are some examples, but because of the details I mentioned earlier, they follow the cloud deployment scenario. And because of that, there were a lot of issues with those, most of them related to being hacked. And when you're putting together child data with hacking, data getting into the right hands, there were a lot of issues, and a lot of these products failed because of that. So our approach here, what are the challenges? Data privacy, obviously, very important data not to leave the device. The safety, obviously, it needs to be a safe toy, not to get to heat up or things like that. Battery life, ideally, you should be able to play with it for days or weeks before you recharge it, not to have to charge it every day or so. Fast response, right? The user experience, for the toy to react in real time as a child would expect. Technologies, developing technology for children. We heard earlier about bias. When we develop technology, we know about the bias issue. We're addressing this. We need to make sure that our technologies work for the market, for the consumer that they were intended for. With children, there are special biases as well. We know typical data that are used in training these deep learning algorithms. They are targeted for a normal distribution that, where Caucasian adults, male, will be the most dominant one. We need to make sure the technologies work well with children. So we need to develop the technologies that we'll want to implement in the toy to work well for children. And the last one, which is very important, is how to have a toy that will interact naturally with the children. If you think of how a child interact compared with an adult, it's very difficult. Even simple interaction like asking for a yes or no question, you might get a audio yes, no, you might get a nod, you might get a gesture. This is a natural interaction with the child. You cannot expect to a certain type of answer, and if that doesn't come, you don't know what you do. So this multimodal interaction with children was very important from the start. We need to be, the toy needs to be able to hear, to see, and to feel, and to talk back just in a normal way with all children. So these were the issues that we wanted to address and what we feel they're important. So we know the technology, the computer vision technology. This is what we do as a company. We didn't have at the stage a lot of experience in audio technology especially for children. So we team up with Sobox and NYG, and we apply for the DTIF, the Disruptive Technology Innovation Fund, and our proposal is called DAVID, that Peter mentioned, stands for Data Center Audio Video Intelligence on Device. And the project started in May last year, and it will last for 3 years. So right now we're right in the middle of the project. So what we plan to do here is to develop a platform that is capable of this multimodal interaction and has ultra low power consumption and the power to analyze all this data coming from multiple sensors on device without the need to communicate with any server. And the market that we would like to use this platform for initially is the smart toy market. So we'll use our hardware that we develop internally, our computer vision technologies, together with the audio technologies from Sobox in order to make this happen. I mentioned Sobox, our partners, the company in Dublin. They're specialized in developing audio technologies for children. And the core of our toy is our Ergo chip that was developed for this kind of use cases where it's very important to have a high level of intelligence at the edge with very little power requirements. This is a comparison where the perceived Ergo chip, how it's compared against multiple other options that are out there, from other edge chips to some of the data center levels. And you can see it has an order of magnitude less power requirements compared with anything that is out there currently. So as I mentioned, we started in May last year. We want to build a toy. Usually we're not in the business of making and selling products, but in order for us to prove that, look, this can be done, we need to have an actual toy that will do what we said that it's capable of doing. So we had to design the actual toy. This is how it looks currently. We still work in progress, but you can see it has a lot of sensors that are connected, and LCD for eyes and multiple cameras and so on. We had to design the hardware. We have the chip, but we need to design the hardware around the chip. And we wanted to design a platform that is highly modular. So for example, if you want a certain use case, just a toy that can listen, for example, you only need a small part of the full platform. You can see there we have 3 of these Ergo boards connected to a hub. And depending on the use case, if you want a toy with all kind of technology, you can use all 3 Ergo boards. But if you want a simple one, you can use a single Ergo board. And so this is how it looks. It's a very small board. If you see the image in the middle, underneath is a board of Raspberry Pi. So the hub is on top, and then the 3 Ergo boards are on the very top. So this is how it looks. It's a very small toy, a very small board that can fit into any kind of toy. But with 3 Ergo boards, this has a lot of computational power. And as Peter mentioned earlier, the power requirements is very small. One of these Ergo boards consume as much as a normal LED that you have on a board. Okay, so this, talking about technologies, this is what we do. We develop technologies. Our technologies for vision, face analytics, base analytics are state of the art currently, and they will work even from early days. That's how we can integrate our technologies in different products. Okay, so we want to have all these technologies all running on a single chip. For example, the vision chip, we have all the technologies running in the same time on a single chip with the power requirements that I mentioned before. So we have a face analytics technology which comprises on different multiple networks. We have a network that can detect, a network that can analyze, a network that can do face recognition. We have another network that will do body analytics. We can detect how the child, if it's playing, if it's, we can encourage exercise, things like that. We have the hand analytics that is doing gesture, if the child is responding this way. And a few other technologies on the vision side. All these technologies are running in the same time on a single Ergo chip. The collaboration with Sobox for audio understanding we have multiple technologies that will run on the chip in the same time to understand what the child is talking to validate the intent, what exactly is trying to do, things like that. And the collaboration with Peter's group in NYG, which is very successful for audio synthesis. The toy needs to speak back, but it has to speak back in a way that is friendly for a child, not necessarily Alexa type of synthesis or Google ones. It has to be tuned for children, both in terms of the type of speech, intonation, things like that. So a lot of research going on in there as well. Okay, so these were my slides. So thank you very much.
Great, thank you very much for the great talk, guys. It's been very, very illuminating. We are now going to kick off our question and answers. So I can see that Jerry has posted a question. Thanks, Jerry. And he asks, if you have AI at the edge, what are the challenges in keeping models up to date?
I can take that. Yes, in order for technology to perform well and to keep up with the recent advancements, you need to be able to keep the models up to date as well, to update the toy, the products. So there has to be a way that you can update these models. There are a lot of challenges, of course. You need to make sure the models are still compatible. If they're using some data that is already learned, if the model on the device maybe was updated, was learned something from that particular use case, that state needs to be compatible as well. So there are some issues, but it's very important for these models to be able to update them, being to make them better or fixing issues. So we always take this into consideration to be able to update the models. Yeah.
Great, thank you very much. The next question is actually one from myself. I'd be very interested to know, as you have mentioned in your talk, these are very much cutting edge products, and it's not a commercial product that you're developing yet, but how long do you think it will be till companies harness these capabilities and start producing products that are commercially available?
Yes, I can take it from our side. As I mentioned, we're not a product company. We're not manufacturing products, we're manufacturing technologies. And we need to be able to demonstrate to the manufacturers what is possible, what is the next thing they have to be considered when they are planning for the next products. So once we have the toy ready, we will show to the manufacturers, look, what is possible, and it's up to them to plan for the actual products. This means usually a few years. So once we have our project finalized, if a manufacturer decide to go ahead, implement something similar, this will mean another couple of years to have it already on the market.
Okay, great, thanks. You know what, I think it actually somewhat ties in with a question that Terlak has just posted. There might be an element of kind of crystal ball gazing with this one, but he is asking, super toys may last all summer long, but where are we headed with this technology? It's quite an open-ended question. So yeah, I guess, Peter, do you want to take this one first, and then Gabriel, you can come in afterwards?
Good. Going back to the original Brian Aldiss science fiction story. So Turlock's obviously a science fiction buff. So the David came from the Steven Spielberg movie, which was based on that story, in fact, which, if you're not familiar, has a little boy who's actually an artificial boy. So I think that's what Turlock's getting at. I will say we're kind of some distance away from, from true artificial intelligence. But some of the technologies that are being developed on this project, for example, the computer vision, because Experti has a long background, going back with Photonation, going back 20 years. The number of networks are actually quite impressive, and the computer vision, this toy will be able to recognize, obviously it's not FBI face recognition, but it will recognize individuals. It will know if a child or a parent is basically talking to it. And will also have, reasonable intelligence to interpret emotions or facial expressions. So we're certainly seeing something quite interesting, especially as this is happening at the sensing level. This is, this toy will know things. Now, how that's actually going to translate into practical products is a good question. Because interaction, I still have trouble with Alexa, so I think children don't always speak too good. We're targeting in some cases children that are even in the 6, 7, 8-year-old age, possibly younger. I believe Experti is doing some experiments, to figure out the different age groups. And our partner Soapbox is an expert in this area. I think it's short term in the toys market. The initial games will be relatively simple, but as the technology matures, and there's already a version 2 of the accelerator on the way, we're probably going to get to multi-core processors. We're going to see other chips like this appear on the market. I think we're still a long way from what I know Turlock wants me to get to is, are we creating cybernet here? And I think we're still very, very far away from that. But what we are seeing here is a much more sophisticated type of sensing. And why it's interesting, it's happening at the local interface. All of this data isn't going up into the cloud and isn't compromising your privacy, which is important. But we could probably explore this more in the panel session. So I think I've probably talked enough for now.
Yeah, just to say, I agree what you said, Peter, and this is what we're trying to find a way to solve the privacy issue. Make sure the data doesn't leave the device, okay? And in the same time, making sure that for toys, for example, we create a better experience for children, not to get frustrated with a toy that is asking you to behave in a certain way because the technology was developed for you to act in a certain way because the adults can adapt that very easy. It's a toy that might learn you, but it will, for a child, it will be your toy. Maybe it will learn your name and it will say your name, and you're able to interact with it easier. And from the parents' point of view, you don't have to worry about privacy issue. The data from these sensors, they are consumed as soon as they're captured. They, not even from a harder point of view, no one can have access to this data. So if they fix the privacy issue, we create a better experience, and in the same time not have a toy that heats up or requires huge battery, or you have to charge it every hour or so. So these are what we're targeting, not the self-aware AI and things like that.
Great, thank you very much, guys. As you know, I think one of the main points that you're saying is that, you know, there is no data stored at all. But I mean, given that case, how do you think product manufacturers or designers will kind of validate that the toys are working as they expected as well? Or is that kind of beyond the remit right now of the design?
Yeah, I guess the use cases for these toys, we were expecting at the start of this project that we'd have toy manufacturers, you know, telling us, oh, we want to do this, we want to do that. Actually, they're kind of looking for us to tell them what they can do. So we're learning as we go along here, but it is clear there are products out there that we've been looking at as well. It's not actually been driven at the moment by the toy manufacturers, and I think part of this project is going to be showing them what new dimensions can be added, which is a kind of new challenge for us because we're engineers at heart and we like building stuff, but now we're asked to get a bit more creative. So yeah, it's an interesting challenge.
Could I ask, how are you managing the models so that they don't put, for example, regional bias in them? One of the problems with visual models and with audio models is that they're deeply regional. How are you managing that?
Yes, I can take this. As I mentioned, I have a long history of designing products that are shipped all over the world, and we have a very comprehensive way of testing and making sure we don't introduce bias to a level that the customer will notice that. Okay, so part of our developing cycle, which includes a very thorough QA part, is also to make sure that there is no bias for the regions or demographics that the product is intended for. And for that, of course, data is at the heart of it. And we invested in data since early 2000 by capturing data all over the world in order to make sure that we can also deploy our technologies all over the world and not have complaints or issues with this bias that it is introduced. Obviously, there will be some bias, but not the bias that the consumer will complain about or will notice. So through data, this is how the proper testing of the models, having the right data.
And you can then update the models on the device.
Exactly.
How do you know that the updates are being deployed and you're not embedding future data and future biases?
But
through
updates,
if we the model,
okay.
But how do you know that those model updates are being deployed and consumed?
True, yeah. This is up to the manufacturer, the one that makes products. If it's required, and we did that in the past with mobile phones and other devices, we provide, if there's a need for a fix or for an update, we provide that. And usually the manufacturer is in charge of making sure that these updates are deployed. But we didn't have these issues for a very, very long time. Again, because we take care of this on the data side and on the technology development side, making sure once we deploy, we don't encounter issues.
Thank you.
Great. Thanks. Thank you. Thank you to everyone for the questions. And thank you so much, Peter and Gabriel. It's been a really, really interesting talk. I'm sure we could stay here for another half an hour firing questions at you, but we have to wrap up. And, I really hope that we'll have you guys back on again. It's been so interesting about how you built the privacy into the design from the start and all the considerations that it brought along with those. So thanks once again, guys. I'm going to pass on to the next moderator and the next speaker.
Thanks, Karen. Sorry. Hey, everyone, and welcome to this third talk of the itag AI Summit 2021. My name is Emil Munoz. I'm team lead and lead machine learning engineer in Genesis, working in the digital and AI group. So it's my pleasure in this case to introduce our third speaker of today, Edmund Sutcliffe from the Guru team. Edmund is a transformational lead, strategic thinking, and technology consultant and advisor. He has worn many hats during his extensive career, right? Trying to build in-depth knowledge as well on cutting-edge technologies. And in addition to that, he is a great communicator and can frequently be found driven training and mentoring. So his talk today, it's deterministic construction services. Why is this key to regulatory compliance and safety? And we will have a few minutes at the end for Q&A. So please drop your questions in the chat and we will get to them towards the end. So Edmund, whenever you want, you can start sharing your screen. I think you're still on mute, Edmund. Edmund, can you hear me? You're still on mute.
Is that working?
There you are. Yeah, there you go.
Okay, so I want to talk a little bit about deterministic construction. And I want to talk about it because this has become an increasing problem with providing evidence around regulatory compliance. Whether these services are cloud connected and connected to the world, or whether they are embedded in devices remotely, there is a whole series of regulatory frameworks about cause and about implications where evidence about their reliability and their behavior needs to be demonstrated. At the heart of that, we really have to begin with an understanding about what software is. We should be really acutely aware of how risky it is. There are a whole series of studies looking at the unreliability of software delivery, and I don't think this is unknown to the people on this gathering. But I think what has changed is the impact of the regulatory frameworks around people delivering systems and how they impact the business itself in what happens. We're seeing this with not just GDPR, but we're now seeing this with, for example, sensor frameworks on the automotive industry, where the manufacturers of the sensors are responsible for being safe, whatever that means. And then when the part kills someone, people are coming back and looking at what's there to hold these things together. So writing software now has direct impact on the lifeblood of the organization that delivers the software and the components. So understanding that framework has become crucial to the longevity of an organization. There's a wonderful paper from 2017 called The Coming Software Apocalypse. And Nancy Leveson, who really is one of the people thinking most deeply about the problems of complexity and the systems around software development, is saying that actually the trouble with making things out of code is that as opposed to something physical, the complexity is invisible. I'm now working with car manufacturers where their edge components that are doing the sensing contain 100 million lines of code. But they say, well, it's just a small operating system doing this. I don't care about anything apart from the bit I run on it. But in fact, the whole complexity runs all the way down the stack, and managing that has become a real issue for them. The implications for the business, as I said right at the beginning, are relatively clear now. There are those reputational damages about the reliability and the availability of the service. There are the dangers of the aberrant behavior seen in these things because we've failed to categorize and understand what problem we're really solving. Particularly with things that are holding larger scale interactions, we have the difficulties with the security around the services and the data breaches. And in fact, even more common, we're now reaching a situation where people are asking, how did you make those decisions about me using the data you have on me? And being able to explain those and not to embed the biases around those has become a big debate for people. We're also reaching a situation where the insurance markets and the regulatory markets are beginning to put constraints around what's delivered. Certainly in the markets I'm working most today, they're really beginning to address the issues of functional safety, particularly things like ISO 26262, but they're also beginning to look at the implications around the security of these things. Is my IVI, is my reporting system for my heating actually secure and not showing things where it isn't supposed to go? But in fact, we're also having the same problem about being able to make sure that we're reporting and protecting the choices that people make about their systems and where those data go, and all of those requirements about the people. And also, we're having to manage the privacy of the data that we use internally to build the models that we use to look at what's going on. There are regulations, of course, around financial reporting, and they're becoming more involved than ever before. Things like BCBS 239 requires financial organizations providing capital services to be able to report about the entire stack that they deploy and the dependency on third-party services. So actually the regulation is saying, explain the chain about what's going on to hold these things together. And we have the traditional problem, which is we're not very good at defining our constraints, what behavior we're expecting to have from people, what functional and non-functional requirements you have around the system. We've not been good at doing these things, and those reputational regulation and requirements pieces continue to be a problem for us to report and explain to people. For many of the organizations I now work with, particularly those in financial organizations and those in medical organizations, the need to provide evidence about what your service does is crucial. And the implications of not doing that in a reproducible manner typically lead to extradition, orange jumpsuits, and federal prisons. None of those things are good things to look forward to. So understanding what evidence you're collecting, whether you are just verifying the behavior of the system, confirmation of its actions, whether you're looking at also aberrant action and verifying that your tests actually have impact on them. I frequently work with people whose evidence is only about systems behaving as expected. There is nothing about unexpected behavior or conditions they could never think of because people are not thinking about these in terms of fault injection and in terms of the validity of what's going on. There is also the behavior of the system that you're expecting, but also there's this argument about how it maps to regulation, how we validate that the behavior of the system that we put together associates with those requirements that we verify. As I mentioned, BCBS 239 and Sarbanes-Oxley now require you to provide for the systems that are making these decisions bills of material, telling you what the dependencies are and how they sit together. There are organizations providing safety and security who are saying, actually, these updates are minor. They are not large implications. And in fact, you have to provide audit reports to confirm that they're not a complete rebuild of everything. They're only at the margins of what's going on. And for things in the medical marketplace and in the safety marketplace, we're having to make safety and security cases about the changes we make so that third parties can confirm that at least they don't believe we're going to kill everybody every time this goes out on the road. To make those cases, we get stuck with a series of problems around knowing what went into our systems. I'm increasingly working with organizations who are asking the question, do we know who worked on this software? Do we have foreign nationals from organizations that are unexpected who are doing this? Interestingly, people are also asking the question, do we have governments interacting with these systems that we don't know about? Particularly in the cybersecurity space, and particularly after the Edward Snowden report about interactions. People are asking these questions about these interactions and the decision-making around them that mean that we're having to find more evidence and attest to these things as these systems get embedded and delivered to people. That's leading to an interesting problem, which is how to forensically we provide that evidence. It becomes a question of how do we align these things? For me, increasingly, I have a problem with my test results are kept in one place and they are not kept with my source code. So aligning my test results that support my verification case, which support my validation case, they're not kept with my source code. So my test results and my source code do not align. How do I solve that problem? How do I support and align my requirements with the code base I tested? And worse, how do I know how my software was constructed? What environment did I construct it in? How was that environment constructed and where did it get its stuff with? This becomes very meta. I have to go all the way up the chain and confirm I know where the components are and how they sat together. If I'm making these safety or security cases, how do I make these cases? Is it good enough just to write a document in English to say, I believe this test supports this requirement in the standard in this way? Does that get things together? One of the great problems is that actually these cases are frequently made face-to-face to auditors. And when we're making them, actually, they're not necessarily recorded with any clarity. I was fascinated to discover that both SOX and BCBS 239 audits, which I've been involved in recently, have been delivered exclusively as PowerPoint decks. There's no relation to the underlying data beyond the data that is copied and stated in the PowerPoint decks. I cannot confirm whether they're true by looking at the real source code and the real delivery binaries. This has been an issue in legal cases for some time. But what's interesting is these evidence problems and argumentation about how the evidence should be used, which is recorded in most legal cases in a thing called a Wigmore chart, are not brought to the cases we make around the software and making the regulatory case that we have to make in these things. There are also some things where we simply have to stick our hands up and say, we don't know. How good is this? And in those situations, we have to have an attestation. We have to say they're external to our argument and we understand what they bring in, but how they manage them. I've recently been involved in a project where at the heart of the operation is a dedicated Linux distribution. In effect, this is multiple repos, somewhere around 200 different repos, somewhere around 140 million lines of code. And keeping that up to date and tracking just the changes with the open source repos that support it is a problem. This particular manufacturer has brought them all into a single repo. And now we have a job of managing importing those repos on a regular basis and bringing them up to date. And at the same time, attesting that the changes there are good, even though we don't know the individuals involved in doing the changes. We have to accept them in that way. One of the problems I've had with increasing embedded AI in the census has been the fact that I do not know where the models are, and though I will have tested the models, I don't know what bias exists in the models. And because of those biases, I simply have to say, we believe that the organization that did this did work well and was reliable. But we have no more data around it. So those attestations become something that we have to live with, and we have to be able to support that in an argument about how they come together. This is not a new problem. There is a replicability crisis existing in science. We have a whole bunch of people in science hypothesizing after the results are known, they're p-hacking, they're data dredging. There's a failure to record the methodology of how these things happen. And that leaves us without being able to make a case that stands up in court. And that is a massive problem going forward. And there is no way to hold those things in any way at scale. We have the same problem with systems development methodologies. We have a situation where we have a series of cargo cults without common metrics. The better value, sooner, safer, happier, the scaled agile frameworks, the DevOps frameworks, all of these become repositories of cult behavior without common measurements and common recording of attributes, the metadata with which to do these things. Stuart Ritchie's excellent book, Science Fictions, looking at the fraud, the bias, the negligence, and the hype in science, is absolutely explaining the difficulties that we're having with our own reporting to regulators and what comes with these problems. And this is not just systems and software development. This is a general crisis in the way that we make arguments. At the heart of this, we have a more complex problem that we're still to address. And that is to address the issues of reproducibility, something where the instances in which the researcher collects the new data and arrives at that produces the same results. And there's no way to solve that at the minute. For many things, producing a binary identical artifact is hard. So we have another way to make these arguments, which is about the replicability. So we can take data that is similar, and we can confirm that the behavior of the system around things is identical, rather than something being being binary identical. And we can make a case that if we have enough replicability of a system, if we know that it behaves in this way consistently, we can make an argument that that is sufficiently good to make these regulatory cases around what hangs together. So where are we with this? Well, we have to start making a case about how we can put trust in our construction of systems and how that impacts our regulatory reporting and our auditing. And in turn, these cases impact the value of the companies we work for. So there's some conflict of interest between the collection of this data and how organizations wish to present themselves. Where can we assign this trust and how can we put it together? At the heart of this, there was some work done in the UK centered around the Cabinet Office and University College London called the trustable hypothesis. And it raised the following statement. It says, for something to be trustable, we have to know where it comes from. So we have to be able to audit where the source code came from, and we have to know who worked on it and why. We have to know how to construct it. We have to be able to build it. If we can't construct it in a consistent way, if we're unable to reproduce it, then just being able to build it is not enough. There is some non-determinism in the framework. And managing that causes us problems because we don't know why it's non-deterministic. We have to understand that a system does what it should do, and it does not do what it should not do. And it's this second one that's really more complex to manage. We often write software in which we have clear verifications of its behavior, but we select the happy path. We make the decision and discuss how things come together in terms of what they do. The development of techniques looking at fuzzing, looking at static analysis about expanding these things is beginning to make us look to ensure that it doesn't do what it shouldn't do. And managing that is a growing space in which work is being done. I think the last point about the trustable hypothesis is perhaps the one that causes the most debate. Is it good enough that we can construct it once and we can use it? I would argue it's not. If we can't update it as we discover that we have our requirements incorrect, we have our validations not matching the regulations. If we can't update it and be confident that we're not introducing new aberrant behavior in ways that will be detrimental compared to its historical behavior, then we can't put trust in the system itself. And we have to think about our software development in these terms. So putting these things together gives us a way of asking questions about the work we do. It gives us some measures that can be automated, that can confirm that we can place some trust in what we do. So how do we do these things? How do we put trust in what's going on? Well, one of the things that has come out of particularly the DevOps market space is the idea of idempotent, immutable environments in which things occur. The ability to control the execution environment, to have them as snowflakes, historically has been a problem for us, but now we can burn them down and reintegrate them. They become immutable or ideally idempotent, so we can uniquely identify them, and we can put consistent environment in there to confirm that we can construct and test those pieces. We can control the inputs that construct them. We can know that things are within things with good signatures and good controls over change. There is some debate about this. For everyone on this call, you'll be aware of the difficulties with the issues centered around hash collisions. And one of the problems that Git is currently dealing with is that it will have to change its hashing strategies to deal with these hash collisions. But we're aware of them and we're addressing them. We're also looking at our continuous integration systems, where this has become the meme, and we're beginning to not just construct software using continuous integration, we're constructing the construction environments that construct the software in this way. And so we can reference implementations and we know that they're good. With artificial intelligence and with things centered around large data stores, we have some other problems to deal with. One of the great things about random numbers is that we use them in a whole series of statistical techniques involved in machine learning. But actually, if we want to make sure the model is consistent, we need to use the same random numbers because they impact, for example, the way we pack memory. And that changes the behavior of the system because the memory layout is different. And so the memory management underneath there becomes inconsistent. It is not reproducible. This leads us to dealing with the replicability, and this means more statistical testing that delays the rate of change, that has impact on the share value. We are working increasingly with environments where we're producing binaries, where just the compiled tools are generating unique date and times on things, so the binaries are not identical, and managing the date and time strings in things so they can be consistently managed and consistently delivered becomes an issue for us. Some of this is being addressed by sandbox build environments where we can control the date and time of construction, where we can control the environment and the startup memory, and where we can control the configuration of those things, and we can block access to make sure that nothing unknown comes into the system. These have definite impacts on the way that things go forward. And that's a help in how these things come. I think we have another problem to come, and that is to deal with the enforcing and exploiting the reproducible. Constructing software must be exactly reproducible if we are going to say we don't need to do the extra work on replicability. And with the timescales about release, that work about replicability means that many builds have to happen. And in the end, Amdahl's law applies, and we have the problem about the integration of those results at the end, which delay that release. So to do that, we really need to benefit from that great project from the Fedora team and from the Debian team on reproducible builds. Certainly in the Linux marketplace, this has had a big effect. I can now construct reproducibly the core of the Linux operating system, and I know it will be binary identical on the same CPU with the same tool base multiple times. And what's more is I can verify that reproducibility, and I should be doing that frequently so that I reduce the need for me to move from reproducible to replicable with the additional tests associated with that. Identical outputs with different inputs, however, mean different changes. So we can target the software and we can look at where we can also remove unnecessary testing. I'm working with a car manufacturer at the moment, and that car manufacturer, because of their inability to target the software components and because everything is in a mono repo, and the way that their build system works is that they look at the git char of trunk, which effectively is the impact of the whole system. So nothing is identical. They're not caching the artifacts. This is why multiple repos may be an advantage, because they're not changing all of the configs or all of the code. By things being broken out into multiple repos, we can cache them. We know that they're reproducible. We can prove it. When we reuse them, we don't have to revalidate those components. So we shorten our development cycle. We shorten the elapsed time for our developers. We're shortening the costs. We can look on where those impacts are, and we can be confident about our updates because it can confirm what has changed. And we can cache those things. So again, the tests become less of a problem. The cache allows us to reuse them. And so by enforcing and exploiting this reproducibility, we get faster delivery times than we've ever had before. We have to manage this evidence. And managing the evidence is involved. We have to include the documentation, the requirements, the certification criteria, what the build inputs are, and we have to be able to map them at any moment in time to the source code. One of the problems I have with GitLab and GitHub is that they're not aligned to a Git char. And there's no way to say all of these Git chars made this thing at one point. One of the interesting things about people working in the SQLite community and in some of the reproducible is giving me a way to hold a char of the chars of all of the things that are there and storing them. One of the pieces of code I've been working on recently is to put in Git notes and Git LFS contents into the Git repository on trunk that restore and hold on to my artifacts and my test results so that they're aligned with the Git char of the repository. So I can cryptographically provide evidence that I can have consistent requirements, test results, and source code with one Git char that holds them together for the whole organization. So I can make these cases. We have a problem about mapping evidence into criteria. As so often in science and in certification, a lot of this is in the eye of the regulator, the person who does the certification. We need to be able to assert and record these things. In the safety environment, there are tools like STPA, which is about system theory and constructing these environments to know where they are. But in things like the DevOps environment, we don't have any way of saying that we've mapped these controls onto this behavior beyond the spreadsheet, beyond the PowerPoint. And the problem with these artifacts is they're not aligned with the changes that happen in the real environment. And that's really a big problem for people. There's no easy way to hold those things together. And as so often happens, our assertions in the evidence changes and the criteria of the standards change. And so we need some way to map these in so that we can make sure our evidence is argued, I would suggest with more charts, against the evidence that is stored inside the Git repository with Git notes, as Gerrit does, with LFS to store the binaries and the test results. So we're in a position where we can generate from signed environments things that will hold these things together in a reasonable way. I've been working with particularly safety certification, and one of the things that has come along is the need to be able to provide evidence tailored to the standard and to have a deterministic construction service that can hold these things together. It omits things that are not about the safety case, perhaps, that we're making, but also include the management process about the functional safety, the change management, the impact analysis, how we hold these things together. And we can extend it to make sure that we're reporting on the whole chain of how these things come together and what they do. We also can talk about the loss scenario. So we can say we're addressing these problems because we know that we believe that these losses will happen and they're already handled by some other part of the system. And by not looking just at the individual repository or the individual component, but looking at the system, the car as a whole, we're in a position to hold these things together in a neat way. Working with CodeThink, we've gone on to build a deterministic construction service. In fact, this looks pretty much like any CI pipeline and CD environment that software developers are used to. What we are doing is working with multiple repos so that we can cache this data ahead of time so that we save the output more regularly. We're also working on making sure that artifacts are signed and the evidence holds together with it. What's interesting is that this approach finally has got agreement by a standards body, and it's become a recommended way to build systems that are about ISO 26262. This is the first time that tooling for safety has been about the audit trail, the evidence arguments, and the consistent way of holding them together, rather than a case that's made in paper with a bunch of Word documents that you could then have to by hand trace back to the source code. This comes from the source code and the evidence associated with it. In no way is this journey done. There's still more to happen, and it's a gentle trip just to bring these things to a close and to be clear that it moves things forward, but it's not done. One of the things that this approach is doing is confirming variance across multiple repositories. It measures what changes and allows us to say these things have changed, and we can deliver an entire artifact that is then embedded in a system, not just for a single repo or a single artifact. So we can tell the whole story and make the case across the whole story. We record the argument because what we're beginning to put in is the reasoning about why things are done and how those tests move back to the validation and certification. We're reusing the reproducible build approach that came from Debian and from Fedora, and that's giving us reduced effort, and we can speed up the cycle times to get things through the safety case to production. And we're also bringing determinism to the construction environment, the verification, the operation, not just to the operation of the system. And that determinism, by managing the data sets, the code, the learning of all of these things, is moving things forward for people. How does it happen? We're replicating the process and the artifact, as I said. I think that's moving things forward. We've got a whole bunch of metadata around the delivery in the project, so we can start looking and measuring what we do and how that case comes. And we're moving regulatory reporting. It's moving away from a Word document to being a bunch of test results that can confirm the case. And we're using the skills of Wigmore charts that are used in courts of law to make the argument about how these things sit together. So they're beginning not to be debatable, they're beginning to be artifacts that can be reproduced. We're not hiding the science about what we're doing. So the job is not done. There's a journey to go on, but there's a journey that we think we've moved forward. Are there any questions?
Thank you very much, Edmund, for that enlightful talk. And we have a couple of questions already. So Christina Potnar say, Edmund, as we test functionality and look to prove compliance, regulatory as well as organizational requirements, we need an extensive set of data. So how do you advise we go about obtaining the data, given that even tests or validation data must have compliance on its own?
So I think there isn't a good answer. What's interesting is how you want to make the case. So you, certainly for some of the organizations I'm now working for, the way we make the case is we say, this is the data we have from the behavioral systems at the moment that involve these sorts of actions. So for example, we know that humans working in this way, the failure rate in the diagnosis is this. We can say that using the data that they're doing, we can look at that data and we can say that our device's failure rate is comparable or of the same thing. And so it comes back to this being able to make an argument that can satisfy the people. Now, that argument does require some statistical evidence generally. And that means that you have to be able to select the data in the first place. One of the problems in the car industry, and you can see this with Tesla recently, Tesla have been making the case that their self-driving support is safer than humans driving the car. Their argument there is, look how many people kill themselves driving the car and how much damage they do. Our cars have done similar amounts of hours on the road and killed fewer people. I think that argument is weak, but it's been successful in producing, particularly the NTSB and the Euro NCAP people, that it's a plausible case. I think in the end, it's about this plausibility of case you make and sharing that data, but collecting the data in the first place is non-trivial. Does that make sense?
Yes, thank you.
Perfect. And we have another one from Keith Bynes. Great talk, Edmund. Given that at the heart of many deep learning approaches is a complex, practically non-deterministic model, how do we prove these systems in a regulatory framework? And how do we measure trust with these models?
So the approach moves from one of reproducibility to one of replicability. And then the question becomes, are we not suffering from the same problems that Richard Feynman always said, which is it's easy to convince ourselves, it's hard to convince others that we have a system that's replicable. So I think the first thing is that we can do statistical analysis of reruns of these systems. I think the statistical analysis currently is up for argument. I should state here and now that I am a Bayesian, and I carry that as a religious approach. And I do know that there will be others on this who believe that I am a crazy person. I'm sorry, but I am a Bayesian, and so I believe that our data changes our behavior as we learn these things. For a number of the learning models I work with, though, actually, some very simple techniques do give me deterministic output. So, for example, I mentioned that one of the things that we've been doing for some of our models is, in fact, using tables of random numbers instead of using random number generators. And when we're doing these things by replacing things inside the operating system tree so that they are deterministic, in fact, we get to the point where we can make arguments about the reproducibility of these things. There is another problem to be addressed, which is that of the data selection that we use for training these models and the ability to reproduce those data training. Again, I think some of that we can address by managing the training samples and being able to put those under good version control. Many of these training models are fundamentally text-based, and those repositories are available. So again, those sorts of things help. Do I have a perfect solution? No. Like all of these things, we're getting better at it, but I hope we're getting closer at it.
Thanks. And the last one coming from Jerry Carty. Sounds like it's not an AI system specific problem, and we have a long way to go to resolve this for common or garden software first.
So I think you're right. It is not an AI specific problem. What is interesting is that because of the safety case and because of the security case and the regulatory case, they come to software first. And we're learning to do it by trying to get it through the certifications with Exceeda for ISO 26262 and the ASIL certification. I've learned a shed load of stuff that I thought I already understood. And the bad news is I didn't. The good news is that if we're solving it there, it's going to come to other places because the regulatory compliance, whether for medical devices or for financial controls, or whether for security, are coming from government. And being able to report on those is becoming more and more of a problem.
Thank you very much again, Edmund, for such a great talk. And next we'll have a session with a panel discussing AI innovations in customer engagement.
Thank you so much.
To Karen.
Hi, everybody. I hope you're enjoying the conference so far. So we'll give it another minute just to kick off, and we'll play the video while we're waiting. Great. So we've literally just hit 12:30 on my computer here. So I'm going to kick off the conference. So for our panel, you're all very welcome to the itag AI Summit, and I hope you're enjoying the day so far. I think we've had excellent speakers, so we're delighted, and you'll be able to listen to them back later. So thank you very much so far. We're moving to our last slot, which is the panel discussion focused on AI innovation for customer engagement, where we'll be learning some exciting work going on in technology companies based around the west of Ireland. I'm your moderator for the panel today, and I'm Karen Conway, Director of Technology Management, working with Fidelity Investments for close to 20 years. I'm showing my age here, so even AI can't turn back the clock on that one, but let's move on. But while we're here to discuss AI, just for awareness, this year INUI Galway launched a postgraduate level 9 course in conjunction with SkillsNet Ireland, focused on AI for managers. The background to the course is to upskill leaders on what is AI, and they'll break it down into things like machine learning, what is data analytics, natural language processing, how they can be applied to problems, the ethics and the laws that need to be considered, and looking into the future, where is AI going, how is it moving forward? And the key part of this is all of this is without having to download a development environment, because there's no coding involvement in this at all. The idea is that we're creating a course that's going to give you the knowledge to lead a team working in AI. As a student on the course, not only do I find my student card very handy, I'm also finding it very useful to be able to contribute to the AI-focused meetings, have a valuable seat at the table, and it's broadened my thinking to use cases that I probably wouldn't have thought about otherwise. So I would encourage you to have a look at the course. It has another major benefit. It's 100% online with pre-recorded lectures, so you can take them at your own pace, and you can fit it around your home life. So I still have time to ferry my kids to every social event going on that's suitable for a 6 and 9-year-old. But if you have any questions on the course, feel free to reach out to me. You can find me through itag or LinkedIn, and of course, Professor Michael Madden is here with us today, and he'd be happy to field any questions for you as well. So back to why we're here. Let me introduce you to our wonderful panel who's waiting here to join us. So first up, we're going to talk about Edel. So we have Edel Kelly joining us. She's a senior manager at development at Genesis. Edel is working with the field of engineering for almost 2 decades as a developer, and now has moved into engineering management. She's leading a global distributed agile team working on the company's predictive routing product. At Genesis, she's part of a team that pioneers experience as a service. So organizations of any size can provide true personalization at scale while improving employee experiences. Also joining us is Emily Bailey, Senior Director of Data Products and Machine Learning at Rent the Runway. Emily and her team work across the business to optimize both internal operations and the customer experience, with a particular focus on engineering and computer vision applications. Prior to joining Rent the Runway in 2020, she spent her career leading teams and solving data problems at Uber and clean tech startup Opower. Emily's educational background is an undergrad in economics from Duke University and a master's in computer science from Columbia. And a really big call out to Emily for joining us today. It's very early over there on the west coast of America, and it's Thanksgiving. When we did the timings for this and planned it, it seemed like a very good idea to pick this day. But I do want to call out Emily. Thank you for making a massive effort to come and join us today on this significant holiday. Additionally, on the panel, we have Fenton O'Malley, Director of Research, Development and Innovation at Fidelity Investments. I work very closely with Fenton. Fenton oversees all R&D incentive programs at Ireland and from a European level as well for Fidelity Ireland. His role involves the development of new services and products funded by or initiated through R&D. With research collaboration being a key objective for Fidelity Ireland, part of Fenton's role is to build stronger relationships with research institutions and develop a framework engagement to encourage the new business opportunities across Fidelity's global sites. And last but not least, joining us from India, we have Manak Das, who is a machine learning architect at HPE. Manak architects machine learning solutions as part of designing a digital customer experience to a large global HPE customer base. As part of the services R&D organization in HPE, he and his team research and develop scalable, production-ready AI solutions that focus on cost effectiveness, predictive recommendations, and personalized customer experience. Previously, Manak has worked on products predicting customer device failures and also business analytics around customer feedback and support automation. And again, a special thanks for joining us from India today. Hopefully the time zone is a little bit more accommodating, Manak. So you're all very welcome, and thank you so much for taking the time to join us today. I'm going to jump to the questions right now, but in the meantime, there is a chat open, as most of you are aware from all the sessions that are going on previously. So feel free to add your questions in there, and I will check them occasionally and make sure as we're going along that you do get your questions asked. So with that, I've got a couple of questions to kick off the panel. So I am going to kick off here first. So, there's a huge investment going on in AI at the moment. And in a recent Gartner survey, 1/3 of technology and service providers plan to invest 1 million or more in AI over the next 2 years. So maybe just for as an understanding what you kind of do in AI in your companies, I'm going to ask you to highlight where AI has brought innovative change for your company and what value it has provided to you or your customers. I might ask Fenton if you want to take the lead on that one.
Yeah, thanks, Karen. And first of all, delighted to be part of this truly global panel here today to talk about customer engagement and AI. As you mentioned, a lot of the work that I do is with the research centers and looking to try and draw from that rich research experience and accelerate our AI development within Fidelity. So generally across the financial services domain, they probably were early adopters because traditionally they would be very data rich, and that's the main source of information for artificial intelligence and data science in general. So across areas like robo-advisors, like anti-money laundering, fraud detection, customer recommendation systems, risk and compliance, which was talked about a little bit earlier, algorithmic trading, and chatbots. They're the main areas around the sort of financial services area. But to pick one example, and one which is more local, I suppose, we're working within UIG, the NLP team there, the natural language processing team there, with our personal investing team to build a better sort of chatbot experience for our customers. So with a customer base of over 40 million customers in Fidelity, the customer experience is paramount. So the work that we're doing within UIG is to look at giving a more positive customer experience, but also to be able to understand customers' questions, and through the virtual assistant or the chatbot environments, be able to direct them to the right area, and even be able to get them to allow to complete a financial transaction, let's say, from end to end, without having to go to the customer desk. So a huge amount of work there. We're working for 4 years with the UIG on that, and it's very valuable particularly to the personal investing
community. And in terms of the value, I suppose the value is really the improved customer service. That's the number one thing for Fidelity. And the more intelligent, in inverted commas, we can make the virtual assistants or the chatbot, then the better customer experience you have. And that's ultimately the objective here.
Fantastic. And just recently working in chatbots, I realized the ams and the ums, like they add a lot of complexity, and just eliminate them all to try and get to the point. So thank you, Fintan, for the update on what we're doing in Fidelity Investments. Idel, I'll hand it over to you just to give a little bit of background of from Genesis perspective.
Thanks, Karen. You mentioned yourself actually in the intro, experience as a service, when you read my bio, and just to, I guess that's where I'll elaborate, in my contribution to this answer. And experience as a service is something that Genesis has as a vision. It's one of our North Stars, and it's about making a customer feel remembered, heard, understood, and that we believe is the foundation of an empathetic customer experience. And if you give every customer exactly the experience they want every time, an agent who sympathizes while solving maybe a complicated issue, or it could be the other side of the spectrum, like you just mentioned, a quick answer from a bot. Those are the key moments, they define customer experience and the outcome that occurs between the customer and the brand. And empathy, we believe, it builds trust. And then when you build trust, you get loyalty from your customer. And the customer feels known, customer feels valued. So this is what we strive for with our products and our AI-powered insights to make these, the intent and the needs heard. So bringing that all together in tools that customers can use to deliver that engagement. Yeah, so that.
Fantastic. I really liked the experience as a service because, we often think of something that's so tangible, like infrastructure as a service, but like experience isn't that tangible yet. It is that what you're striving toward and driving towards. I thought it was a fantastic tagline. So thanks, Idel. Emily, I'll hand it over to you just in terms of Rent the Runway.
Yeah, and I really loved what Idel said about kind of making the customer feel heard, feel understood. That's a big part of what we're thinking about as well. I'll give a quick background on Rent the Runway. So we don't operate in Ireland, even though we have a really fantastic tech office there. But the way the service works is that it's the world's largest shared designer closet. So any woman in the US can open the app or the website and choose from tens of thousands of styles of clothing and accessories to rent. And she might be a monthly subscriber, so she's doing this many times per month, or it might be just once in a while. Maybe she's going to a friend's wedding or some other event where you want something special to wear. And when you think about getting dressed in the morning, all of us, I think, unless you're one of those people who've caught on to the idea of a daily uniform, it's always a decision, and you want fewer decisions in your day to kind of make life easier. And here we have this service that makes it easier, so you don't have to buy as much, but you have these tens of thousands of styles to choose from now. And so a big bet we're making in the AI space is personalizing the experience for each person who visits, and helping them make sense of that closet and make it work for them. And so that might be, that could come off as, I think, less helpful if they're not getting the right experience. And so where we're really thinking going forward is how can we continue to make this a two-way conversation? And so again, making that customer feel heard, feel like we really understand her tastes and preferences, and not just what's trendy right now, but what is she like broadly, and also what's happening in the world right now, what's the weather, what's on her calendar, and how do we fit into that and make the closet make sense every time there's a different day she's visiting and looking for a different rent. And so for us, what success looks like there is somebody continuing to come back to the service, right? So if they're a subscriber, they're maintaining their subscription, and regardless, sort of this increase in LTV is the ultimate signal that if they're increasing how much they engage with us, more transactions, more times they're renting. And we also have a really fantastic data set. Every time somebody rents an item, they're filling out a survey that tells us why they wore it, whether they liked it or loved it, or how it fit them. And so we have this really important indicator that is how much did people love what they're renting and have a great experience with the product. And helping them choose the product is a really big part of that.
I really like it. And I suppose even outside of the AI element here, like, it is tackling fast fast fashion and, you know, kind of looking at the sustainability element. But very nice. Thank you, Emily, for that update. Manak, would you just give us a quick brief round on kind of where you're working with in terms of the HPE solutions?
Yeah, thank you. So yes, HP, as you know, is a very big company in terms of like the number of products that we sold. So I was looking into the numbers, like the numbers is something around 240,000 different product types that we have actually, it's out there in the market. So we have to support them. So the way it goes is that the customer calls up when there's a problem with the product that he owns in HP. But what we want to happen is that the customer should not even get aware of that the problem has happened. We should be fixing it even beforehand. So that is what we call as predictive maintenance or predictive failure detection. So we have a big AI area in that, so which we call as InfoSight, as well as we ourselves from R&D has also worked on that. And then if we cannot detect that at that point of stage, and if the customer do come, we want to make the process of getting a solution as simplified and as streamlined as possible. And that's where we have the chatbots, which Fintan talked about. We have got something called support automation, where we get all the information, though the customer comes to us, but we already have all the information from the device already sent back to us. And we are already doing the analysis by the time the customer comes to us. And then post that, the whole idea of using AI is to also understand the feedback loop. Okay, we have customer has come to us, we have solved the problem. What is their feedback and where can we improve? And where can we give a better experience next time then it comes to us? So that's where the personalization comes into picture. So we know the customer better, we know what has been his interactions in the past, and then we pitch in with AI to have a better experience next time that he comes over. So all those different areas we have AI specifically for a better customer experience. Yes, Karen.
Fantastic. And I think what's coming out in all of this is it's everything, because we're talking about customer engagement, everything is focused around the experience of the customer, and we're trying to improve that constantly. So that's a great update. Maybe moving a little bit more to AI, like, can you talk to me maybe about what AI brings to your product versus a traditional technical solution? So what made you choose AI? Why was it that over a regular tech solution? So just in terms of that, I might ask Emily if you want to just kick that off for me in terms of Rent the Runway.
Yeah, so I spoke a lot in that first question about how personalization is really our big two-way conversation in the customer experience space right now. And that's a pretty traditional area to bring AI in. There's a really large data set that you have here, which is everything other customers have looked at, engaged with, how they have felt about it, and like the reviews that they've left. And it's really hard for a human to make sense of all of that, but the scale of the data is really well suited to an AI solution. I can zoom in a little bit there. One of the specific problems that we tackled that we actually didn't start with as an AI problem. So personalizing the experience comes in a lot of different kind of flavors. One is like, what is the type of thing I should be renting? Like, am I renting this sweater today? It's November, it's cold in this part of the country that in the world I live in. I shouldn't be renting a sundress probably. But then you get to the next step, which is, okay, what size should I wear? And really, I mean, this sweater probably would look good on a lot of people, but certain shapes just would never flatter my body. And so not just what size should I wear, but should I rent this at all? Is it going to fit or flatter me? And that was a problem that originally, like, a lot of designers are trying to solve. They're designing for different people. And so like you as a customer, you might shop at different places and you know that your size X at one place is not the same somewhere else. So we have hundreds of designer partners that we work with. And so for our customers, it's really, really challenging to say, like, all right, I'm used to shopping at a few retailers. Then I join Rent the Runway, and all of a sudden I'm simultaneously shopping at these hundreds of brands. And so we were originally just trying to provide a lot of information that the brands were giving us, but it's not always perfect. And so started looking at AI solutions here because we saw others in the industry doing that. And again, we saw that this is a very similar collaborative filtering problem where we could leverage similar algorithms for recommending styles as we can for recommending sizes for people to rent. And I mentioned our fit data earlier. So this survey that we collect with every rental, we have some of the best fit data in this industry. And we know this because some of the leading papers on fit algorithms use a data set that we open sourced a while ago. So that was a really good indicator for us that AI would be a good solution, not just for this space, but for the data that we have available to us when everyone else was already using it to build their tools.
Great. Yeah, you can clearly see how it would work in terms of that. Like, yeah, and maybe that's why my friend who's size 6's dresses don't fit me. Maybe I need to work with this AI algorithm. I'm going to hand it over to anybody else who'd like to add in. Ida, would you like to jump in or?
Sure. I think, well, AI can deliver. Okay, I got a notification there from Zoom. AI can deliver, in our case, the next best action, the next optimal action. So you can see how that improves the customer's experience in a contact center. Back to the word experience, but so we have tools that we work on every day, such as predictive engagement, our AI platform, or predictive routing that I work with, and they work hard to determine the next best action. And that, we're using AI to route those incoming interactions, whether they're voice or digital, to the right place at the right time. We're jumping in to assist at the optimal time, based on the customer's history or that of others, like what Emily's describing with their data that we have leveraged that provide that key information at that key moment. So that there's how the customer experience is improved.
Oh, fantastic. Yeah. And I suppose back to, again, one of the drivers behind AI is around the predictions, that's what it's very good at, looking at the history and getting in there, the predictions at real time. Manak, would you like, I see you coming off mute, if you'd like to weigh in here?
Yeah, maybe just to add to Emily and Idel. So being technical architect here, so what we found is that if we sort of break down the AI problem in a way like, okay, we get X from the customer and we want to return back Y to the customer. And if we see that the Y that we are aiming to return back to the customer is not definitive, so it's not like a definite answer that we expect. And there's a tolerance for an error out there. So which indirectly means that we can really predict and which won't be 100% accurate. Then we know that we are talking about some sort of an AI problem out here, which can be met with an AI solution. But if the Y that we intend to return back to the customer is definitive, then definitely it's not an AI problem, right? It's more of a traditional the way we are talking. And the other thing that we also notice is that X, what we expect from the customer, if it is also like a limited list, maybe it's a very large list, but still a limited list. So then also it's not perhaps an AI solution that we are talking here. When we do not know the possibilities of the different values that the X can take, the different ways the customer can interact, then only I think we are again talking about something related to AI, like a chatbot. We don't know what the customer will type. But if we had known that he would click between A, B, C, maybe we do not need a chatbot, right? Just to get an example. So I think that's how we sort of figure out when to use AI and when to use not traditional solutions in our case here.
Yeah, I like that definition now, I have to say. It's very clearly either it's known or it's unknown. And probably AI, then you're looking at the unknown, but thank you. Thanks, Nick. Fintan, do you want to weigh in? And then I'm going to maybe do a little bit more around the skills and languages.
Yeah, I suppose more generally, if you look at when to use AI versus not AI, you're looking at what the capabilities of AI can bring. And in a world that's changing so fast, and certainly customer expectations are raising, you're looking at things like, I think that Emily and Adele mentioned as well, are more around the personalization, more of a personal experience. So with all of the change in demographic and with the change in customers, etc., you need the system to be able to, I suppose, learn from the customers and then adopt or adapt their service and make it more personable. So you've got to have that capability then within your offering to continue to learn and to try and fulfill the customer expectations.
Okay, yeah, great. And I suppose now, like if I was to think about it, because there's people on this call maybe here that's thinking about, oh, will I start an AI project or not? And you have to kind of just try to get to the bottom of whether it's the right idea or not. But what would you kind of recommend as the skills you needed to start working in a solution? And maybe like, you know, we all hear that they often end up as POCs. How do you move beyond a POC and get it into production? So maybe Del, I know you kind of have a fairly big AI solution in production. So I'm going to ask you that from Genesis perspective.
That's a good question, because do you need an AI project? And do you have, our customers, our Genesis customers, they don't need any skills in AI to leverage AI. And, you know, for example, predictive routing, the product I work on, we've released it in a discover, try, buy mode. So our customers can, using very straightforward UX, run a non-impacting benefit assessment, we call it, on their data. And it comes back to them with a report of how this ML component will impact their business and what the outcomes may be. And then they have the option of switching it on in a test mode for maybe a fraction of their traffic, or to enable it on their traffic, and continuously get reports and feedback on how predictive routing is impacting their business outcomes. And that, for our users, they don't require any special skills, you know, and that's a key point there. Do you need to start your own project, or do you take something that's provided as a service like we offer? Now, however, the project team that's required to deliver that product to production, that's another story. That requires, from my experience, and I've been 2 years at Genesis now, a very diverse skill set. A group of people from very different backgrounds. And it brings its challenges, certainly. We have large scale solutions in Genesis. We have many services, and machine learning is one component of many. But to add it to the software development lifecycle, it doesn't fit in always in the traditional sense. So, you know, there's we need to have, and such a to go back to the skills question, we need to have that. So it starts at research. So we have a data science team that we work closely with. Then you have to bring that all the way through to production. Production where customers, our customers anyway, that we've had some for more than 30 years, assume all of the pillars of software, security, stability, scalability. To get it from research to that requires data science teams to work closely with machine learning engineers that work closely with software engineers. I mentioned UX, it's key. We need to have, and we have a really great UX team that we work really closely with to deliver UI that is easy to use and understanding and can explain. And we have product managers working closely with customers. I mean, I could go on, and and it's a great time to work in software, to be honest, because you get an opportunity to work in these projects. And yeah, everybody has their area of expertise, and we all come to the table, but we all have to be able to. We need to be conversant in all of these other areas also, because we need to talk to each other, because all of our inputs are key to the success of the project, to bring it all the way through from research to product. Yeah, so it's
I love it. Because it's not just one, and then it's not like you can probably get a tiny bit of bias if it's kind of one particular area, but you're bringing everybody to the table to help make that decision. Yeah, it's fantastic. I'm going to elaborate a little bit maybe on the question for if anybody's going to open it, and it's something you did mention, Edel. You know, you talked about kind of like your customers at the end take the product. They don't even need to know about whether it's, you know, they don't need to know AI. So maybe in terms of the skills and stuff like that, you might recommend, when maybe if I move on to maybe Emily, if you want to take it after this, but how, you know, maybe around the build versus buy as well. So obviously you're building your own solution. And do you at any point like feel that maybe a buy solution would be better in terms of maybe some of the algorithms you're using or anything like that?
So I would agree with everything Edel said so far. And then I think before getting into the build versus buy, there's one more lens I would add to that, at least from the problems that we encounter, is some solutions we'll see may not require the same, I think, definition of production. And so the big differentiator that I tend to see pop up is whether something is like what we would call an online versus an offline problem. So does the customer need to be getting these predicted outputs made in real time? Like, are we doing this on the fly? Does the model need to be live, like consuming inputs and returning results during like a user session? Or is this something where we can make predictions in advance, store them, and then serve them through more standard engineering interface? And I think that can really differentiate the team that you need to build. It's still, the same questions about what the product looks like, how it's designed. You're thinking a lot about that user experience and engagement. But within the data team itself, you can have a little more separation between who's working on the science and who's working on the software. And I know that in some cases that's helped us. That's been a form of POC, but it can also be the final solution. And it really depends. Like one example is if you're changing your prices with some regular cadence, for instance, and not, so like a ride sharing company might be changing their prices with every single interaction because it's based on immediate supply and demand. A retailer might be changing them weekly or monthly. You don't want that much spin. And so that's something that you could do with a very different back end. And I think for that component to be able to make those decisions intelligently and really staff your teams properly, having a leadership who understands what those differences are, who's had extensive experience to both, is a really important part of the team as well. And in terms of build versus buy, there are a few differentiators I see. Primarily what's core to your business. So I think getting back to that pricing example might even be like, that's something that a lot of companies want to keep in-house, right? Because the price you're setting for something is very tangible to your bottom line. Another lens I look at is what data do you have? Some solutions really require your specific data. Others might be buildable on global data. Like a lot of tech solutions will leverage a global corpus anyway. You're not collecting just strictly the data you use. A lot of vision-based solutions at this point in time, companies aren't collecting such enormous amounts of vision data relative to what's out there that models are available on. So I think those are the two big questions I always try to ask myself, is how important is it that we as a company or an org own the definition of this problem of the data, of how we define whether it's successful, and then do we have the data to make it a reality? Great.
That sounds good. Manak, I'm going to ask you to jump in, and given that you're a machine learning architect, you're probably going to tell me it's built all the way, but I would be interested to hear, your opinion on this. And maybe if you want to talk a little bit maybe about the technologies and the languages, if you want to throw that in there in your build solution.
So I would fully agree with Edil and Emily, right? So it is the data first thing that we have to look into. Like as an example, in our case, when we were building a solution in chatbot, we found that certain areas like where we need to support HP specific terminologies or HP specific lingos and product details and the product support examples, right? So it's not very easy to use off-the-shelf products like Google Dialogflow or maybe some Amazon Alexa or whatever. So to bring it to the architecture and then train them and then use it. It's far easier to have our own solution, right? But for a normal conversation like the generic things like, okay, like the initial conversation, when we talk to the customer, when we greet the customer, when we take a feedback, those whole things can be used using a right off-the-shelf product like Google Dialogflow and others. So I think data plays a huge role. And when we talk about data, the privacy also comes into picture. If I don't want the data to go out of my enclosure, I would not send it to a solution that is out there in cloud. So which also sometimes makes me build it as against that directly use it from cloud, because most of the solutions that we are talking as a service solution, they're all hosted in cloud. So that privacy comes into picture. And the third thing is obviously the architecture. I can get a tool, but the tool has to talk to my data, to my systems. So does it make more sense to integrate it and spend time and energy and resources and maintain it over time, or does it make more sense to use the present architecture and have some solution on that, right? So those three areas. And I'm not saying that we always build, right? We would actually not build at all in case we can live with something that is out in the market, because go-to-market speed is paramount, right? When we talk to customers, so that is there. And from a technology perspective, I think, and So there are very good frameworks out there. Presently, it's a very good time to work in AI space, actually. So from previously, I think around 5-6 years back also when I was there, we used to hear the hardware deficiencies because we did not have that much power to crunch so much of our data. But now the hardware is so easily available. Even in the cloud, it's available. If you can do it in-house, it's available. We have cluster solutions like Spark, Hive, which can work on a clustered hardware. We have GPU solutions like TensorFlow and PyTorch and others. So it's a beautiful time to work on because the software is out there, the hardware is out there, and you can actually build scalable solutions with few lines of codes and nothing like it. So having said that, I think it's always better to think from a life cycle of a data science project perspective, get the data, which is ETL, extraction, transformation, loading, process, explore the data, visualize the data. We need a visualization tool also out there, which can be Tableau, it can be even R, Python inherently has their own visualization tools. And then we have finally get it into a model shape, which has to be in production, which Vijay was speaking. So I think we need solutions which can be pushed to production. So we need to think when we design the solutions from that angle. So things like TensorFlow solutions has got their own TensorFlow serving, which helps us to put it to production pretty easily, which is something that we also do in HP. So yeah, so those are the different areas. So, and the language, I think things are becoming more or less language agnostic. I know there is a lot of fighting between Python, R, Scala, Java, and all that. But what really happens at the end of the day, you get a model which is language agnostic. It should be like a TensorFlow model. It's actually language agnostic. It is finally used it can be served through a C++ web framework. It can be served through a Python web framework. It can be served through a Scala. So that's how it is becoming. So I think without focusing on the language, if you focus on the concepts and the frameworks, that might make better sense. That from our experience, yeah.
Fantastic. So I don't have to go back coding. So, or did you say I only needed a few lines of code to use those products?
Yeah, that's true, actually.
No, it's great, but I do get what you want about the build versus buy. You know, it's not an easy decision. I don't think it's one that you can just say, oh, well, I'm doing this route. Like, it does need investigation to see what it can bring to the table. Just in terms of wrapping up this question, I am going to hand it over to Fenton, and then I'm going to welcome anybody to put questions into the chat if they want to, just while Fenton's finishing this up. I have a few more questions myself I can ask, but of course, we'd welcome the audience.
Yeah, I think, you know, I mean, the input from Idel, Emily, and Manik has been really, really great. And if I was to sort of summarize or look at some of the key points there, when you talk about the skills, there's no doubt that you have to have that end-to-end sort of organizational input into the development of an AI solution for your business. So right across your operations team, your customer service team, and your technology team. And then, you know, I like what Emily said about the difference between the software and the science. And traditional technology organizations would be very strong on the software side. And when you look at the skill set piece of it, the focus really should be now on developing the science element of that to augment the software piece of it. So, and then finishing up, you know, Manik talked a lot about the different data sets and being able to, I suppose, not personalize it, but the need to make it sort of, you know, product specific, whether it be HP or Fidelity or Runway or Genesis. So the danger of the buy versus build is that you end up getting a solution that you really don't know how some of those decisions are made. Brings you into the whole explainability and the ethics piece that was talked about so much earlier on. So, you know, I'm sure there's some frameworks you can buy and then build on top of those, and that might be maybe a good solution.
It is true, because that algorithm is just a black box, like, you know, exactly what's going on. We don't know if the bias is there. We don't know anything else about it. But I suppose you made me kind of think maybe of another question, actually. And, you know, in terms of like an AI, you know, there's AI behind your product. Do you think the customers care, like, or do you actually think that's a selling point? So like if you go out to customers, say, I have an AI solution, do you think the reaction is good or bad, or that they don't actually care about that? Just because I'm really thinking of now in terms of they don't actually know what's in the algorithm. Idel, I might ask you to lead that one just in terms of that area from a Genesis perspective.
Yeah, so I know there's been a lot of discussion today around ethics and trust, and I think you can't just deploy your AI and leave it there. You have to be responsible at the time of the deployment and also accountable throughout its entire life cycle. And we need to strike a balance. I think it depends on the use case sometimes. You know, if it's a balance check or something straightforward, I doubt people care. But if it's life impacting, career impacting, health decisions being made based on it, but to share that with the end user, the product in use needs to have that component of explainability so that it can be shared. So to understand the fairness, to prove that, you know, with testing and the sharing of the results, that the model is fair. Our own general manager, he blogged about this recently, or some time ago, and he called it, you know, he mentions these 3 pillars, this concept, to be responsible for the outcomes, you know, to have the ability to explain the algorithm. So, you know, you understand how the model makes decisions, to show transparency on the data sets that are used. You know, a human or an algorithm, they can either introduce bias. So transparency will help us mitigate that. And finally, fairness can mean different things in different contexts. You know, this is not black and white. No, and it's an emerging area. I think that we need a systematic approach to it across the board. Yeah, would be where my opinion.
Yeah, because we have seen the headlines, you know, like hiring companies using AI algorithms and they're eliminating a certain cohort, or, you know, long-term offenders versus ones that we feel won't re-offend again. And again, there's bias built into that. And, you know, we've all seen that. So, you know, absolutely. And would anybody else like to weigh in terms of that question? Benton, I see you off mute.
Yeah, I know one of our developers who specializes in NLP was on a panel recently, and she talked about, you know, the accuracy of the models and that, and she said, you know, even if we have 99% of, you know, your model accurate, then that 1%, if you take Fidelity as an example, with 40 million customers, what's 1% of 40 million? I don't know. 400,000. Like you might be on target, you know, with 99%, but then you're leaving out all of these other customers. So it has to be obviously explainable and all of that, but you also, it has, you know, there's the continuous learning element to it, and updating and modifying and improving aspect to this technology that, you know, is new for everybody to have to cope with, and to ensure that that the models are up to date and accurate.
Great, thank you. There's a couple of questions in actually on the chat, so you probably can see them yourselves, but I'm actually going to direct the first one from Michael Madden over to Manik. I think that's probably more suitable for you. Put you under a bit of pressure there, Manik. There are some open source frameworks and solutions that you have mentioned, Manik, and data sets, as Emily's mentioned, which have really accelerated R&D and AI in recent years. However, do companies see problems combining open source with their proprietary solutions?
Yeah, the answer is yes. So to give an example, right? So like we enable customers to come and search for their own solutions for the problems. So they can come to support.hp.com and then they just find the solutions by typing the problem. Now, the way we do it without going to much details is that we use a proprietary search solution to do it. But as with every other solution, which is off the shelf, it has its own limitations, and we need to sort of use tweak the ML piece of it, tweak the metadata piece of it, tweak the way the data is structured. We are using another solution right now to structure the data in a graphical manner so that we can sort of tag each and every document in a way that it is more readily usable for different contexts. So yeah, and on all of those, mostly we do using open source technologies. And HP also has got a great reputation, not our team per se, but the overall HP has a great reputation in contributing to open source projects. So it's not only that we consume, we contribute to also that open source. So yes, so open source along with proprietary tools are used to solve problems. None of it alone can do the whole thing. Most often than not, I think that is the case. Yes, the answer is yes.
Great, thank you. I think, ethically, I think it's very good that HP is contributing back. It's like kind of giving back to what you get. So fantastic. Is there anybody else that would like to add anything to that question? There's a couple of more questions in if nobody wants to, and I can jump on. So Emmer is joining us as well. Great discussion. How are the respective companies defining the success criteria to consider the adoption of AI and machine learning a good decision? Example, looking at ROI and customer satisfaction. So I think that was kind of one of the things that, and maybe even now I'm going to add to that about kind of in customer engagement, measuring that as well, just in terms of that question. So I might just hand that over, Emily, if you want to just take the lead on that one, maybe.
Happy to. So I think it depends really what stage of the project you're at, right? Like if you've just launched this AI solution, the first signals you want to look at are whether people are engaging. So these really first order interaction metrics. So you can imagine like how much they're clicking on something or they're interacting with a chatbot. They're totally different ways to define this depending on what the product is. But over time, what you're looking for is ultimately the impact on whatever the highest level metric is that your company cares about, right? So for us, that's going to be the lifetime value of a customer. Ultimately, are we increasing that? Are we making people want to stay a customer longer and be a more engaged customer? And that's something that can be really challenging to measure over time. So often you're looking for a proxy metric that correlates really tightly. If you're measuring something in an A/B test, you don't want to keep this product unavailable to a large portion of your customer base over a long period, just so you can measure how maybe their interactions with the business changes over a multi-year time frame. So that's something I've definitely seen over the course of my career of wanting to understand whether these impacts are, kind of a novelty effect, or if they persist and retain value. And then I saw you mention specifically ROI and whether that comes up. And it certainly does, but I think one of the things I've always seen with AI solutions is that they pair well with knowledge that your solution will scale. And so even at a point in time, perhaps where your ROI may not be positive, like it may take a few years to amortize, it may require knowing that your company will grow significantly to amortize. But if you had waited to start until your company was large enough, or maybe that product line was large enough for the ROI to be positive, you'd be far behind and you'd be scrambling on a build versus buy decision and maybe forced into a suboptimal place. And so I think all of those lenses are important, in addition to choosing the right metric of deciding how you evaluate it differently at different points in time.
Yeah, you're making me think of like early adopters versus kind of the late adopters, and at what point do you decide early adoption is the good choice at that stage? Idel, I'm actually interested in your reply to this because it's experience as a service, so it's a little bit like less tangible to measure. So I'm just wondering, in terms of like again the ROI and the customer engagement from a Genesis perspective, how do you measure that?
So in our projects, I'll talk to you about predictive routing, the product that I'm familiar with, and we have our customers identify their key performance indicators. So this varies depending on the customer. So it could be a reduction in transfers of calls within the contact center, for example, or a reduction in average handle time, which would be the time that the agent's speaking to a customer. We also have other indicators, next call avoidance. So that would be customers do not need to call back within a week with the same question again, which means that's clearly that interaction was addressed by the right person with the right information that first time. So those are metrics that are that can be then tracked, of course, and can give you insight as to how the models are performing.
Fantastic. Yeah, great. Thank you. I'm not sure if anybody else wants to weigh in, but I do have a good question in here from Keith Bynes. So thanks, Keith. How did the panel think the proposed EU regulations on AI will affect their AI strategies? So I might hand that over to Fintan, actually, maybe to just kick that one off.
I think I think it's going to be a game changer. And I suppose when we look at EU and the regulation and compliance and the risk framework that they're coming out with that was mentioned, I think by Ivana earlier on, that is something that's going to definitely focus the minds on the whole area of ethics and explainability and all of that. So I think it's going to help improve it, obviously, because back to the talk about trust, you know, if you have anything in place that will, you know, give you a credible sort of scoring, if you like, in terms of the risk and the regulation side of things, then that's a good thing. But yeah, and just while I mention it in terms of the EU and Ireland and the government, I would recommend anybody who hasn't already downloaded the AI government strategy. It's a really good document, and maybe Joe can put that up on the chat later on. But it covers everything from all of the different areas of AI across, and the way that the government can support some of these areas, including a lot of the European research work and these type of regulation frameworks that are being proposed at the moment.
Yeah, great. I'm just interested actually from this perspective, Emily and Manak, like the fact that you're not based in Ireland or the EU, like, do you find that you actually have to read up on any of this, or do you kind of learn it just the fact that there is locations here in Ireland? Because I think the EU can be kind of stricter on some of our regulations compared to the rest of the world. So I'm just wondering how you handle that not actually being based in Ireland.
So I've worked at a very large global organization before, and always saw that in the data space, like GDPR is a really good example. I think the EU and then within the US, certain states really lead the conversation on these topics. And so I think any leader in this space, regardless where your company exists, where your customers exist, it's really well served to follow those regulations and conversations that are happening, because they really lead what the rest of the world is going to think about and consider. So I think it's probably a different lens that I put on it. It's more of what's my 3-year, 5-year, 10-year plan versus what might be coming down the pipe tomorrow. But it certainly is a nice early signal of what we need to be thinking about. And it's definitely always on my radar. So this one in particular, I think is, yeah, I hadn't seen the Ireland response yet. So that's something I was really glad to learn about here.
Great. And I actually see Caroline's after posting it up there for anybody to look at. I had a quick glance at it earlier, but yeah, it is definitely worth a read. So Manek, do you want to join it just in terms of that, just from an EU perspective?
Yeah, I think in HP, I think the customers are mostly global customers. So they have got bases in every other country. So we have to be very strict in our compliance. So I think GDPR, as Emily was saying, so that is one classic example. So we actually overhauled all the systems, all the data sources, all the places where we keep the data, the databases itself, to ensure that we meet the GDPR timelines on time, right? Because of the fine and the PIN and the other things that are involved on it. So yes, we take it extremely seriously, and I'm pretty sure any regulation that would come, and we have got members in our architecture team, in our product team, who tracks all of them, right? And we are basically, we do it before time. So we are tracking, and we ensure that all of them are met. Yes, and that's irrespective of geography, because we have customers who can span in India, in Ireland, in US, and many other countries together, right? So we cannot take any chance. Yes, that's how we work. Yeah.
Yeah. So Idel, do you want to weigh in there, or I can just move to the next question if you want and hand that over to you?
I don't mind, Karen. I guess it goes back to maybe briefly mention what I said at the start, how transparency can be used to mitigate any bias.
Yeah.
You know, and that's what we can do.
Perfect. Yeah, so I'm actually going to hand this question to you, Del. I haven't read it yet, but what the panel think will be the AI application that will disrupt our day-to-day lives in the near future? What's the next big thing coming that we're not aware of, or what do you think?
Okay, interesting. So we're always trying to be innovative in Genesis. That's trying to always bring new things obviously to the market. We use a framework called design thinking, which is, you know, workshops that we have where we put the human at the center of the whole process and empathize and come from that with ideas. And certainly that's the process that we would use. What it would be, wow, I don't want to say something outrageous.
It probably will happen.
You might have to come back to me. I'm trying to think what I should say.
Absolutely, I totally put you under pressure there. Would anybody else like to weigh in? I'll just tell you one. Like, we had Catherine Enright as a speaker a couple of months back. She's from Valio. She was a fantastic speaker that we had in here as part of our forum. But she was talking about in the future, like, we won't be driving cars on streets. Like, it'll be confined to like basically like a racetrack, and that's where you'll be driving your car. So like, if you want to take your car for a spin, it'll be not in the towns or anything like that. That will all be kind of motorized, you know, non-driver cars that you'd be taking, kind of more like non-driver taxis. And so our cars will be disappearing off us. So, but I see Emily here and Fenton off mute, so I'll ask you to weigh in here as well.
I'm happy to follow you, Fenton. I think you were off mute first.
Yeah, I think, yeah, and something Nidel would be familiar with is certainly the AI wearables. And if you're a runner or it's like, you know, if you're into sports, that's certainly something that people are well familiar with now. And, you know, when we even listened to the Experti presentation earlier on about AI at the edge, I think what's fascinating from a societal perspective is the advancements in medicine, and how AI is helping through you know, like vision detection and that. To pinpoint, you know, treatments and that. And I think if you map that with AI wearables, that whole concept of Medicare, particularly for the older, is going to be massive from a societal perspective. So that's something I'm looking forward to tracking and see how that evolves.
That's a great answer, Fenton. Actually, preventative medicine. Yeah, that's a really good answer.
And I have seen actually kind of some videos about kind of AI, and they're like embedding the chips into people's brains and they're hooking up to the muscles, and people with their prosthetic arms can now actually physically lift stuff. So you're starting to get that mobility back, which is a fantastic point. Yeah. Emily, I'll hand it over to you.
I'm really excited about the nexus of this space and energy efficiency. So I have a lot of friends who work in the energy efficiency area, just from past companies I've worked at, where that was just like Rent the Runway, a really big focus of sustainability. And right now, the way most electricity grids are structured, there's pretty limited sharing and storage at the individual's level. And the more we're putting solar panels and electric cars on the grid, there's many more options for storage in a smaller way than like the massive power plants are capable of. And so I think there's these kind of micro storage opportunities need to be managed by a larger scale intelligent solution, and could really massively change the way we generate and use energy, which would be, you wouldn't maybe feel it day to day, you wouldn't think about it, but it would be markedly changing, hopefully, the climate, the way we spend money.
Fantastic, great. I'm going to leave that at the last question, closing up, but I am going to ask Manik for his opinion on what he sees as one of the big disruptions for the future.
Yeah, so I would go a bit technical, right? So I think the AI is meeting its limitation, the way the AI is structured right now. As an example, you talked about cars. So I think the reason why I read and hear the self-driving cars are not coming to the street is because you cannot even have one single error out there. So there is no tolerance. You cannot hit one person and say, hey, 99.99% the car has been working fine, right? So I think you need to, so those are the areas where AI is hitting limitations. And one of the areas that I see myself is that what we call as quantum machine learning, right? And I think even the Fidelity and others might also be thinking about that, in the sense that the whole cryptology, the whole idea of protection based on the RSA cryptology that we have, they're all at risk. It looks like the whole, and it will also hit the communication industry. So because basically bringing quantum computing in the machine learning area means that you are basically exploding the amount of computation that you can do, and amount of combination that you can crack. And that would mean it's overall in the area of finances, or overall in the area of communication. And I don't know when it's coming, 10 years, 20 years, but when it's coming, it's disruptive for sure.
Hopefully it comes in our lifetime. I really want to thank the panel. Thank you very much. So we've 3 minutes left. So what a fantastic panel we've had today. Very futuristic thinking, and very knowledgeable in your field. So I do really appreciate you all for joining us today. Emily, happy Thanksgiving. You may get to go back to bed, or you can put on the turkey, but thank you very much for joining us today. Just to wrap up in terms of this, we do have an AI community out there. So everything that's available to offer is out there on itag.ie. So I'd certainly ask you to go out and check that out. There's also details for the AI for Managers course out there. Somebody has reached out to me here to drop them an email directly, and I will do that. I've taken down your email address, and I'll drop you a note directly today after this in terms of that. But I really, really appreciate your time for that. In terms of wrap up, I'm going to hand it back to Professor Michael Madden, if he's still around, to do a finish up and say thank you for everybody for joining us today. All right, take care. Thanks.
Thank you. Bye-bye.
Thank you very much, Karen. I think that was really interesting panel discussion there, which you handled very ably. I guess my webcam is on. I'm not sure. I can't quite see myself in the preview there. Anyway, so I think this was a really interesting half-day discussion of the AI Summit. It was great to see all of the different presentations that we've had this morning from the speakers from Ivana this morning, and from Experti and then Inequality, and that collaboration there, as well as from Edmund Sutcliffe. So I think there were 3 very interesting talks that covered a range of different aspects of AI. And I thought and then this panel discussion that we've had for the last hour, it's been really interesting to hear about how companies are taking steps to put AI into practice and to use that in innovations to engage with their customers. So I really appreciate all of the great work of these speakers, and I'm very grateful to Sarah, to Emir, and to Karen for moderating the talks. It's a good job, and in particular, Karen, at the end, you did a lot of work there as moderator to moderate that panel, and that was excellent. And thank you also, Sarah and Karen, for talking about the degree programs that you have experience of in your Galway. Great to hear that these are people are finding these useful. We designed these programs in collaboration with our industry partners in response to kind of demands that come up from opportunities that companies see and requirements that company has. So we're very grateful to have that. We're very grateful to have that feedback from companies. As you can see on screen there are lots of ways to connect with us. You can find us on LinkedIn and the website of itag.ie, the Twitter, and what's it called, Instagram and so on. And there's a newsletter you can sign up to on the itag website. And you can watch on the itag Atlantic YouTube channel videos from this. They will appear in that in the future, but also there are the videos from previous itag events, such as recent cybersecurity events, such as the Atlantic Festival, are all available on the itag YouTube channel. So if you'd like to look back on former discussions on itag, I'd really encourage you to go there. So thank you very much, everybody. Thank you for all your engagement. I really appreciate it. And as Caroline mentioned there in the chat, if you go onto itag.ie, you can join the AI Deep Learning Forum and connect more strongly with us and stay up to date with what's happening in AI in the west of Ireland. Thank you all very much, and we look forward to seeing you at future events.
Great, thank you.